Da terça-feira passada já.
Mas posso sentar?
Não, mas fica aí a mandar lá de baixo.
Eu só não pensei que não faria.
Pensei que já estava ao bocado de campo, mas era um bocado mais calhar.
Eu pensei eventualmente, pronto, talvez o Carlos depois faça. Queres que eu possa mandar para o teu e-mail?
Eu queria assinar o que mandei, cara.
Olha, mas não quero que posso mandar para o teu e-mail? Se alguém precisar
Tens a foto agora?
também tenho uma coisa aí.
Tens? Está aí?
Tenho, já o conheço.
Espera aí, deixa eu ver.
Eu já fiquei escaldado. É suficiente.
Vocês vão. Tem tempo de passar ou. Tem? Ok.
Já estão todos ocupados, são três. Estão todos ocupados. Espera aí, todos já os vamos. Já estão todos ocupados.
Conseguiste ler? Conseguiste ler?
Consegui. As aulas já bati esse texto, já não vou ler. Não, já vemos os dois. Já bati esse texto.
Good morning, everyone. Thank you for coming back from tomorrow, who's in the room. Thank you, everyone that's following us online today. I hope you enjoy our presentations. Here at the University of Aveiro, as you know, we have hosted our RISCO unit that is focused on research in the domain of civil engineering and really driven through societal challenges like the developing of resilient cities through smart and constructive solutions, safe and sustainable infrastructure. Our strategic areas are the risk assessment of the built heritage, conservation and rehabilitation of built heritage, and sustainability in construction. Yesterday I did not have the opportunity to obviously announce the Best Poster Awards. We had a pitch session yesterday. We had over 30 posters, and the most voted posters are here. I would just say the first authors of the posters. So congratulations to Jorge Fonseca, to Marcia Lima, and to Raquel Matos. They were awarded the three best posters. And obviously, I would like to thank everyone else for preparing their posters, because it's very important, obviously, to share your research progress, your ideas, and it was very important for us as a group, RISCO, to showcase our research. So thank you very much, everyone, and special congratulations to the three of you. There's no particular prize, just a pat on the back, but thank you very much everyone for preparing the posters. So let's get down to exactly what we'll be doing today. We have 3 panels, and now we see we have external entities, we have invitees from other research units, and the idea here is obviously to strengthen our links to these entities which we collaborate with, and obviously with other research units that are here represented, and give you an idea internally and also inside the campus, other research groups. So we have 3 panels. The first panel will start with focused on the assessment and mitigations of risks in the built environment. So we'll have a lot of presentations. Very diversified in the sense that we want it to be as representative as most of the research that we develop. A second panel on sustainability, construction, and efficiency of resources. And a third panel on the built heritage conservation, rehabilitation, and safeguarding. So here we'll have presentations that will be focused on the rehabilitation conservation in a non-structural point of view and structural point of view. Once again, thank you all for being here in the room again, and thank you everyone that's following online. I hope it's very fruitful, very interesting for you, and obviously we won't have a direct interaction with people following online, but we can always be contacted by email, and obviously feel free then to interact with us after this session, after this day. So thank you very much. I hope you all enjoy the day, and I would ask particularly the moderators to keep us more or less on time, because it's a big risk and it's a big challenge at the same time. So we have like good coffee breaks. Our coffee breaks are 30 minutes. So the idea of the coffee breaks is obviously to interact, to have the possibility to discuss and to chat. So I hope everything goes well, and I will give the word to our first moderator, Professor Villarreal, here professor at our Civil Engineering Department, and the first coordinator of our research unit, RISCO. Please.
Thank you, Romeo. Good morning to everybody. We are starting our first panel on the risk in the built environment. I would like to, first of all, thank to the speakers. We are going to have 5 invited speakers. Thank you for coming, and also to say hello to the audience. And each speaker will have between 12 and 15 minutes. I will give the opportunity to 1 or 2 questions at the end. And so it's everything I want to say for the moment, because time is necessary for the speakers. So the first speaker will be Professor Carlos Coelho. He is an assistant professor with habilitation in Civil Engineer Department of the University of Aveiro. He is the president of the Specialized Commission for Coastal and Marine Zones of the Portuguese Association for Hydric Research, and he is one of the Portuguese delegates of the PAANC, the World Association for Waterborne Transport Infrastructures. So, Carlos, you will talk about development of numerical tools to mitigate coastal erosion risks. So please take the floor.
Thank you.
Good morning, everyone. So thank you for the organization to invite me to speak a little bit about my research. or the research we are developing here at the Civil Engineer Department and the Research Unit. I will talk about the numerical tools that we are developing to try to contribute to the mitigation of coastal erosion risk. Coastal erosion is one of the challenges that the coastal areas have to look at. Also overtopping and flooding events and climate change. All of this needs to be seen. And so what we can do about it? Should we protect? Should we do artificial nourishments with sediments? Should we think about relocation of populations? So our work tries to contribute for the answers to these questions, and we do that developing numerical models to support decision making. And so the presentation will be, we'll have three main chapters, so three main topics: numerical models to support decision making, then the research we are still doing to improve these numerical models, and the cooperation that we have to develop a knowledge society. We think that the coastal management needs to take about some steps to have a proper management. First, define the priorities where we should do our interventions. Then discuss scenarios. What should we do in those risky areas? Design those interventions, and then discuss cost-benefit assessment to support the decision. And so, to support these 4 steps of management, we have 5 different tools that were developed here, and we call those group of tools COMASO, Coastal Management Software. So the first one is, we call it Serão. It's a first assessment tool to evaluate the risky areas of the coastal zones. Requires just a few amount of data, very easy to apply. It's developed in GIS and is available at the internet. It was developed in collaboration with the National Laboratory for Civil Engineering. Then, after identifying the risky areas, we should go deeper and try to discuss the process and what kind of interventions we should do. We have developed one-line shoreline evolution model that allows to discuss different kind of interventions in a long-term, medium to long-term perspective. And so this was developed during my PhD and then was continuously improved by our researchers here, but also in collaboration with Porto University. Another model to discuss the cross-shore process, mainly related with artificial nourishments, where to perform a nourishment in the submerged part of the profile at the beach or at the dune. This model is also a simplified model, considering several different processes, and it was developed firstly by the Lund University in Sweden, where we were collaborating, and now we have also this model with some capacity to discuss artificial nourishments location in the cross-shore profile. If we go for structures, we should be able to design these structures. This allows us to estimate the construction costs, also the maintenance costs a long time, and so we have again a tool to evaluate the dimension of the structures when we go for this option. And finally, the cost tool that integrates shoreline evolution model with the pre-design of the structures model, and add this cost and benefit assessment, trying to discuss in a medium to long-term perspective what is the physical performance of different intervention scenarios, what are the economical performance considering costs and benefits. And it was also developed here in the department. So this is available at the department, and now we are improving these models, working in several different aspects. This is the team that is related with this area of coastal issues, postdoc, PhD and researchers, and we are working on improving the coastal erosion risk assessment capacity. We are looking in detail to artificial nourishment performance, and this is adding continually inputs to LTC and CS model. Overtopping and flooding, this is an important aspect, and we are improving our XD coast and the coast tool. Discussing different kinds of interventions, detached breakwaters, we are increasing the capacity to simulate this kind of solution, and also geocylinders applied for coastal protection, and with this we are improving LTC. How to evaluate the land use to define if it is important to keep the land or we should allow shoreline retreat by erosion. So we need to evaluate land use. This is good for the tool coast. And also the graphical interface, trying to have integrated tools and considering all the 5 numerical models. So the PhD students' topics of research are this. The PhD ongoing, the topic of research are this. And so these 7 topics are improving our numerical modeling capacity. Adding to this, we have the ongoing projects. I will just refer 3. This is INCA. INCA is coordinated by us, is a Portuguese Foundation funding, aims to define a coastal adaptation action plan to the municipality of Aveiro. Have an important participatory approach. We are near the stakeholders, discussing what is the land use value, what is the preference for the stakeholders, if they want to protect, if they think about relocation, if they prefer the nourishment. Also, we are improving our modeling capacity about the longitudinal advancement design optimization. So, should we increase the level of the structure? Should we allow some events of flooding, overtopping and flooding? What is the best option for this? So, this is one ongoing project. The Portuguese Environmental Agency is with us on this project, and also of our municipality. Coast for us is applying the coast tool to 3 different coastal stretches in Portugal. This is a result of a spin-off that at the end of the PhD of Marcel Lima that developed the coast tool, we were able to create a spin-off, and this spin-off applied for funding. This is an EEA grant project, and is allowing us, this spin-off at a price, and now we are improving our shoreline evolution modeling capacity, and also defining better ways to achieve the cost and benefits definition. Finally, SunTrack. This is a research project coordinated by the physics department, so we also collaborate with other departments here at the university. We are tracking the sand, color sand, to see how the sun moves. So we have monitoring data that is used to validate our numerical models, and we are trying to couple the LTC and CS model runs, trying to have long-shore behavior and cross-shore behavior together in a medium to long-term perspective that is not common to perform in other places. So this is the interface that we are getting from these coupling models. And then, with these models, we are trying to answer the questions of the society. So I will just refer some of the models that we are using in some projects related with problems that mainly the Portuguese Environmental Agency asked to us. So this is the study of a sun bypassing system at Aveiro and fevereiro inlets. So we are discussing if it is good or not to pass the sun from the north part of the breakwater to the south part of the breakwater, mitigating the erosion problem in the southern part. To do that, we were in a consortium with a big team, and we were applying these three numerical models that were developed here, trying to contribute for these questions. Another one, this is discussing the feasibility of having a detached breakwater here in front of the Vagueira beach. So this is a consortium with the National Laboratory for Civil Engineering. Aveiro University were also in this study, and we were applying LTC and coast tools to try to contribute for the answers to this, if it is feasible or not to have a detached breakwater here. Third one, this is at Algarve. We have at Quarteira this field of groins, and we were discussing if it is good or not to remove some of the groins and increase the recreational area, and also considering this with the artificial nourishments. So in this situation, we have applied LTC and XD coast. This is with the municipality of Lolé, and again with Portuguese Environmental Agency. And finally, we were discussing an artificial nourishment at the Caxias Beach at Oeiras Municipality. So again, working with LTC and CS model, trying to evaluate if we can have improved beach here for bathing. So this was a quick overview of the research related with numerical modeling that we are performing here, and that application to answer questions of the society. I should say that last week this was recognized by the Aveiro University that gave us a prize in cooperation related with this work with the society. And so that's it. Thank you for listening.
Thank you, Carlos. Is there any question for Carlos? Everything was clear, but I can.
Always have one question if the others don't. No, I think it's very interesting work, and I noticed that there is a good involvement from some municipalities and the Portuguese Environmental Agency. Is there any other type of clients that might be interesting to take, so you can place this kind of development, R&D development, that should be interesting for, I noticed also a company that is a startup that was, so what kind of other type of clients you got from, apart from the municipalities, which of course are at risk at the moment?
Well, the coastal erosion problems are the entity that should take care of that in Portugal is Portuguese Environmental Agency. And in some cases, municipalities also have, well, if the central government, central administration is not considering that, the municipalities can add some inputs, and so they are the main clients. We also have some work with some other administrations, so all public entities, and then, well, a little bit more related with some specific development, we can have some collaborations with companies. R5 is a spin-off that was created, and we work a lot with them, but we are also frequently invited from other companies to make a consortium, to work with them, trying to answer to public works that well, we need to be.
Thank you, Carlos.
Okay.
I would like also to add one more very quick question.
Okay.
What is the degree of the confidence of all these tools, and if they were validated against real situations after the simulation and later, or let's say some years later, if you have compared already, or it's still not?
That's a good question. Well, trying to predict the future is always difficult.
Of course, because
there are
a lot of many variables in this.
There are a lot of variables, and so it's not easy. We have a paper that is to be approved. It was approved with minor changes, so we are trying to work on that with some predictions that we did in 2012. I think it was in 2012 for 2018. And so now we were looking to those predictions, trying to evaluate the results, if they were good or not. Of course, there are several different aspects that we need to consider. What was the wave climate that we predict for the future? One thing, we tried to, in that paper, we tried two different wave climates, and we saw that the better prediction on the wave climate is very important. The better prediction on wave climate represents the better performance of the models. So if we can know the wave climate, we can have good results. I would say, well, of course with some degree of certainty, but I would say that helps a lot, and it gives us a relative behavior, comparing different interventions.
Okay, the very quick one. What are you doing with these tools? Are you trying to commercialize them, or is just for your?
I would say that consulting works. So if the companies come to talk with us, we use them to give them the results they want.
Thank you very much for your very interesting. Oh, sorry.
Just one small question, Carlos. Are you conducting any work? I don't remember. Probably you are doing that. And if you are comparing the CS model with or applying the CS model to the artificial nourishment that Aveiro Port Authority and the Portuguese Environment Agency did last year, or in order, responding a little bit to your question, if you are comparing monitoring results, so real data, and with the results of CS model, or do you think you can do that in a nearby future?
I think we can do that. We are not doing that at the moment, okay. But we have a PhD that can look on that, so maybe we should do that.
Okay, thank you very much for your very interesting
thank you.
Talk. So, the next speaker is Vitor Silva. I just will give some words about his work. I have to say that I for all the speakers, I cannot describe all their expertise, but I have to say some words for each one, and I have chosen this for Vitor. He's currently a researcher of RISCO and conducting studies in seismic vulnerability and probabilistic risk analysis in countries such as Turkey, Italy, Nepal, Portugal or Peru. In addition, Victor Silva is the seismic risk coordinator at the Global Earthquake Model Foundation, coordinating risk activities in several projects in South Africa, California and Sub-Saharan Africa. So please take the floor.
Thank you very much. Bom dia a todos. I've been lucky enough to present in many places around the world, but I only get nervous when I present here in the Department of Civil Engineering, so apologies in advance for that. So the title of the presentation is Risk. It's not good and it's about to get worse. And I know that is a dramatic title, but I think we live in dramatic days, don't we? So I will explain in a second what do I mean by that. So a few years ago, I think in 2014, I started analyzing this figure, which was released by the World Bank. And I also thought it was a little bit of an exaggeration of what we might have in the future. I don't think that anymore. So if you think that basically the risk that we have, disaster risk, is the area of this triangle, then we know that this is going to be affected by hazard, by vulnerability, and by exposure. And in the first maybe 6-7 years, I was facing this disaster risk thing as something static. Now I've been trying to do something different also within the scope of some of the projects here at the Department of Civil Engineering with some of the students. So there are three components: hazard, exposure, and vulnerability, and I would like just to talk a little bit about how I think some of these components might change in the future. When we think about seismic hazard, usually we don't think about climate change, right? We don't think that climate change is going to make more earthquakes in the future just because temperatures might rise, with a few exceptions. For example, we have a seismic hazard model for Europe. We have specific seismic hazard model for Portugal. We have also some global seismic hazard models. But we don't necessarily expect that the ground shaking is going to increase due to global warming. We might, however, expect secondary hazards to change because of climate change. Secondary hazards connected to earthquakes. For example, on this event that took place in Indonesia, it was a magnitude 7.5, and there was this massive landslide slash liquefaction, okay, which obviously caused a lot of fatalities. This is what we see over there in the middle. So this is one of the very important secondary hazards from earthquakes, and I will come back to the landslides in a second. The other part is liquefaction. So I took these photos in January this year. We were basically in the middle of Croatia trying to find places where, despite the fact that the earthquakes in Croatia were quite small, magnitude 5, close to 6, but there were like evidence of liquefaction. The photos are actually not very good, but the owner of this house told us that actually the house settled 10 centimeters. So it's obviously a lot, so it just severed the connections from the house to the surfaces, to the water and to the sewage system. And in this photo, maybe it's also not very perceptible, but these houses are now basically tilted to each other. So basically they have to stop the construction on the second house until they make sure that everything is safe. So we have landslides and liquefaction, and one of my students actually analyzed 42 liquefaction events in the past in different parts of the world. We analyzed underlying conditions from the soil and also obviously from the different earthquakes. And she came up to the conclusion that actually precipitation and the water table are two parameters that are extremely important in liquefaction and landslide. And the problem that we have with climate change is that we expect sea level rise to increase, right, in many places around the world. So the water table is also expected to increase, which in turn is probably going to increase the likelihood that we're going to have liquefaction and landslides due to earthquakes. The same thing is also true for the extreme precipitation. So we can see that perhaps, for example, for the particular case of Portugal, in the summer not so much, but on the winter we can see that we can expect extreme precipitation in a lot of places, and we can have landslides even without earthquakes. But now imagine if the soil conditions now are more prone to this type of hazards. And for example, by the way, also in line with something that Professor Giladial was mentioning previously, what if we test this? So we test a machine learning model and we compare with past events. The correlation was relatively good, but then we also tested, well, what if these historical events that happened, for example, 40 years ago were to occur today? Now that the water table is closer to the surface and there's much more precipitation. So for example, for the particular case of Montenegro, we came to the conclusion that there would be way more areas there would be prone to liquefaction if this event were to occur today. So this is just on the seismic hazard. So perhaps we don't expect more earthquakes, perhaps the ground shaking will be the same, but the secondary consequences of those earthquakes might increase because of climate change. Just to come back now to this triangle of doom, and I just want to talk very briefly about the vulnerability aspect. Why do I think this is going to get worse in the future? Not because of climate change, but because of, first of all, cumulative damage to natural hazards. So if you think that there's an earthquake, the building will be damaged. So in subsequent earthquakes, you might have already some damage accumulation. But it doesn't have to be earthquakes. It could be storms. We saw this, for example, in '80. There was this huge cyclone, and then basically it really damaged the buildings that then were damaged in the recent earthquake in the south of the country. So different ways that the building can increase the vulnerability. Also the unregulated modifications, and we sort of have this in Portugal. Not necessarily adding more stories to the building, like we see, for example, in countries like Nepal and in a few other places, but more, we need to create a store at the ground floor, so we just remove walls and we hope for the best. And then ultimately, there's the aging effects. And from time to time, in Portugal, we do hear about this on the news, a building collapse or some parts of the building collapse due to aging effects. There's not even an earthquake, but still the fragility of the buildings increases. I will not go any more in detail on the vulnerability because this would be something that would take all day to talk. What I would like to come back is to come back to this triangle and focus a little bit on the exposure. And we saw, for example, Professor Carmen talking yesterday about the influence of this component in risk. So here at the Department of Civil Engineering, we've been calculating seismic risk for a long time, almost 10 years now, for Portugal, within the scope of some projects within the Science Foundation in Portugal. We have created exposure models, and what is this? It's basically the number of buildings, the type of buildings, the cost of the buildings, the people that we have inside of these buildings at the parish level, what we call freguesia, but we have the data even at the final resolution. And those type of outputs, we really need them in order to calculate risk. But the problem that we have is this dynamic of exposure, and sometimes we don't have this perception of how cities are changing, but for example, there's this time lapse from Google, and we can see that sometimes just within 20 years, you go from having almost just a village, just a small settlement, and then suddenly you have like a mega city. So in a lot of places around the world, this is quite, it moves very quickly. I think it has been the case with Portugal, for example, in the 80s and the 90s. Now things have slowed down when we look at some satellite data, but it is still obviously a very valid reason for the increase on the, let's say, number of buildings. This changes very, very differently around the world, of course, right? We have countries like in Latin America, Sub-Saharan Africa, that the population growth is extremely high. And we actually tested this, and we have developed some models for Africa, and we came to the conclusion that for some countries like Nigeria, like Ethiopia, like, for example, Tanzania, all the infrastructure that exists today is going to be twice that much in 30 years. Okay, so it's not a long time, it's 30 years. And everything that has been built up to today in some of these countries is expected to double in the next 30 years. And you could tell me, well, population growth is not that, let's say, strong in Europe, right? For example, in Portugal, we know that the population is decreasing, and a few places in Hungary is decreasing. Well, it is true, but in Europe we have, for example, immigration, and we also have, thankfully, strong economies. So maybe not that much on the residential side, but on the commercial and industrial side, we do expect increase on the built environment in the next 30 years. And we work with the World Bank and the European Commission to check this in Europe. And this is, for example, the increases that we expect for most of the countries. And for most of the countries, we expect the building stock to increase between 15 and 30%, depending on the economy. So how do we do that, and how do we've been doing that? So first of all, let's look at the past. And we live now in a day that we can look at the satellite images since 1974. For example, we have here for Aveiro. and see if according to those satellite images, did we have buildings there already or not? In 74, in the 90s, in 2000 and 2014, and we can start understanding what were the places that become urbanized. The second step is why. It doesn't follow a random pattern, right? If you see that this is not random, we can see that there is some patterns here. So why did it develop like this? Professor Kamini talked about one of the models that exists, the slope model. We use that model. We also tested different things about, well, let's check all the underlying conditions. And this is downtown of the capital of Costa Rica. Basically, we check how is the slope, the elevation, the roads, socioeconomic variables, the proximity to towns, the proximity to schools, to hospitals, amenities. And basically, we gave this to first to a multi-agent model, but then again to artificial intelligence, and the system starts learning why things evolve this way. So it starts testing, weighting different variables. We keep comparing with the observations, and we keep testing this in parts of the country that were not included to train the system, and we see if we manage to predict the evolution since 1970s up to today. Once the model has been calibrated, okay, now let me go crazy, and let me try to forecast how exposure is expected to evolve in the future. This is again the capital of Costa Rica, and this is how we expect urban fabric to evolve in the future. Not just in terms of area, but the types of buildings, cost of the buildings. We expect reinforced concrete, we expect massing. We did the same thing using a much more simplified approach for Europe, so using a Monte Carlo Markov chain. And again, the idea was the European Commission wanted to understand what are the places that I'm not worried today in Europe, but I should be worried in the future because of this urban increase. So I will just say now that, okay, I talk about seismic hazard, I talk about vulnerability, I talk about exposure, but so what? Okay, so we have models today that can predict the future of some of these components. Well, I would like just to show very quickly an example of how this was used, for example, to come up with a risk management plan for Turkey. The problem that we have is that this is the present risk. If we do nothing, the risk might increase because of all the reasons I just mentioned. There are several international agendas like the Sendai Framework for Disaster Risk Reduction that Portugal signed, Portugal ratified, Brazil also ratified, so Italy also signed on this. So basically, all these countries made a commitment to decrease seismic risk, to decrease disaster risk. We might choose a mitigation strategy, but if we don't do things, let's say, strategically, then it might not be sufficient to meet the target that I need. This was exactly the thing that we had to do, again, for the World Bank, for Turkey. So we estimated the risk today. This is the average annual losses at economic losses at one of the administrative levels for Turkey, and this was used in 2002 to develop an insurance scheme for the people in Turkey, for the residential building stock. Then we start predicting how many realizations. There's a lot of uncertainty in these models, and we start predicting how we expect the urban fabric in Turkey to evolve in the future. And with that, we know that the current losses in Turkey are about 700 million. And basically, if we continue building this way, so following the same construction practices which are followed today in Turkey, probably this is the most likely trend in seismic risk for Turkey. So then the World Bank told us, okay, what if we magically now make sure that every single person in Turkey will follow the design regulations? They have a modern design regulation, and basically all the buildings will be up to code. Well, then we can change our model, and we see that the risk starts to decrease, because now I have more buildings. Okay, I will have more buildings, but they work a little bit better. But this was not sufficient, because we can still see that the risk increases. So then the World Bank told us, well, what if in addition to that, we make sure that it is easier for the population to retrofit their buildings through schemes like, for example, the one we have now in Portugal, Fundo Ambiental, that basically the government subsidizes or helps household owners to improve their buildings. So in that case now, we still expect the risk to increase up to 2040, but then finally in 2050, we would have already something smaller. So this is just my last slide. I just wanted to say that using such tools, I think it is possible for us to start predicting a little bit better the way that we expect the risk to evolve. I just wanted to say that, unfortunately, there is a strong correlation between building cities and urbanization and places that are not good for build due to natural hazards. We tend to build close to coasts, and we just saw the presentation from Professor Carlos about coastal erosion. A lot of times on coasts we also have subduction areas, so we have high ground shaking because of earthquakes. We also have floods. This is something we did for Willis Towers Watson, and basically the height of the polygons, it's the number of commercial, industrial and residential buildings, and the color indicates the level of seismic hazard. So you can see that high seismic hazard in places with a lot of buildings. Then with Fathom in the United Kingdom, they then brought the flood hazard, and you can see that in a lot of places we also have high flood hazard in places with a lot of people. And finally, if you combine the two things, we can see that in a lot of places we have high seismic hazard, high flood hazard, and these cities, they have huge population growth because there's also this migration from rural areas to urban areas. So just to finish, I think we know more about disaster risk than we ever did, but still we see that there's this huge increase in economic losses, in human losses of course, and the number of occurrence of disasters. Current knowledge, tools and models I think can help a lot in informing this design implementation of measures, but also for risk awareness. I think in a lot of times I actually don't think that sometimes these tools make their way into the actual risk mitigation measures, unfortunately, but I think they're also quite powerful in raising risk awareness and making sure that people think a little bit about it. And I don't want this to look like too dramatic because luckily I've been exposed in Portugal, but also in a few other places where there are actually some interesting programs to reduce risk over time. So thank you very much.
So, time for one or two questions again. Yeah.
I would like to ask Vitor, these very interesting tools, very well developed tools. Instead of looking only at predicting, how can they be used, for example, in building back in terms of resilience? They're very good for forecasting,
Yeah.
but how can we use them in the, I would say, in the aftershock, in post-emergency action?
Yeah. So we have developed stuff like that with USGS pager system. So I think maybe some of you have seen that every time there's an earthquake, usually there's this very nice PDF that just in one page shows the immediate, let's say first order, if they expect like high losses or low losses. We have been working with the United States Geological Survey to do that. So the module that they're using to calculate the ground shaking was actually developed by this foundation that I'm associated in Italy. So they're doing that. In addition to that, we also connected our tool to this shake map, which is basically just an hazard footprint, just a ground shaking that is usually estimated there. So we've been also working basically all the exposure stuff that is produced here can be used for rapid loss assessment. I think we didn't take more steps towards that, also because that's basically their territory and we wouldn't want to be competing with them, so we've just been providing models and tools to them. But there's this European project called RISE, where they're doing that in Europe. So basically there's the pager system for the USGS, which is a little bit global, and now Europe is going to have its own system, hopefully quite soon.
Any other question?
Just one. Thanks, great as usual. I really like the Zubarno model, as you know. One issue is that though that's a comment that we also got from our reviewer, they consider a business as usual model. So there is no, for instance, implementation of policies that could reduce the urban growth, for instance, in hazardous areas. Are you planning to do anything in that direction, or you considering to do so, or for now?
Yeah.
Not yet? Yeah.
So for example, we had to do that for Costa Rica. I'm not entirely sure we would be able to do that at much more larger scale than Costa Rica. Costa Rica is a very small country. So when we were predicting the future exposure for Costa Rica, we were lucky enough that my student is from Costa Rica, so I was involved with some people there. So when we were predicting, for example, where buildings were going to exist, we had access to basically to the different policies. And so to understand where buildings cannot be built, but also what type of buildings can be built. For example, no adobe, no reinforced concrete buildings with more than 3 stories. So this type of information. So we had access to that to predict the future, but we also start investigating the urban planning more like a risk mitigation measure, right? So for example, for the floods, we should not build in this particular area. For the faults, we should not build too close to the fault. So if we do, then the design, the design ground shaking should be a little bit higher. So we did that. I think the challenge is more when somebody asks us, do this for Turkey,
Yeah.
It gets a little bit more complicated.
Oh, great, thanks.
Okay,
Thank you.
So next speaker will be Carlos Couto. He is now assistant researcher at RISCO, and he has been working on the fire behavior of steel structure, and he started to be an expert on stability of steel structures, mainly under fire conditions. And apart from that, he started a new, a new line of research using machine learning models to predict the fire behavior or the resistance of steel members. So, please, Carlos, the floor is yours.
Thank you very much, Professor Villarreal. You should have said in the introduction that we are working together since 2007. So I would like to publicly acknowledge that and thank you very much for the sharing of knowledge and all the life experience that we had. And it's not always that we have this opportunity to say publicly this, so thank you very much.
Time to start.
Yes. So thank you for the invitation. I will speak in the next minutes about steel structures in fire, which is the line of research that I've been working, but now with a slight twist with using machine learning models. And the first slide that I brought here is to show you a boat, a steamboat and a Concorde, and it's very interesting to see that in less than 100 years all the technology progressed in order to reduce the travel time from 7 days to 3 hours and a half in less than 100 years. So this analogy is interesting because now I'm trying to use these machine learning models not to reduce the travel distance, but to make the models more accurate. So we can have predictive models that are more accurate than the analytical ones. So first the boat, so the analytical models, and this is some formula. I will not go into detail, but this is a formula to calculate the resistance of a beam in the case of fire, and this is the formula present in the Eurocode 3, so part 1, 2, and this depends on some factors, and during my PhD, so in collaboration with Professor Villarreal and also Professor Nuno Lopes, who were my supervisors, and also Bin Zhao from CTICM, we reached the conclusion that there were some phenomena that was happening, and this is the effective section factor that we developed, and by using this factor, we could improve the answer or the prediction ability of the response of the beams in the case of fire. So we include some changes in the original proposal from the Eurocode by including a plateau, some different imperfection factor that depend on the effective section factor, and some consideration of different moment distribution. And by doing this, we could reach some improvements. So in these charts, and I will be showing some more in the end of the presentation, you can see here on the x-axis, so this is the value predicted by the numerical models, and in the y-axis you have the prediction from the methods, in this case from the present rules of the Eurocode, and on this case, the new rules, the new generation, so the proposal that we made. And we can see here, by looking at the correlation factor, we can see the improvements that we brought by this new proposal. So a coefficient of correlation equal to 1 will mean that we will have a perfect correlation between the predicted results and the given values. So you see here how we could improve these results. But now the Concord, so the machine learning methods, and my intention with this presentation is not to lecture you about these machine learning models, just to highlight some of the main aspects and some ideas for you. And we can observe that during these recent years, we can observe that there is a growing trend in the use of these techniques for the steel structures on the left, and also applied to the case of fire on the right. And on this exercise, I was trying to give some ideas of why this is happening, and one of the reasons is because we have data now. We have lots of data that we can use to develop the machine learning models. And another aspect is that we have access to computational resources, so high-performance computers, and this is helping in developing also the models. And of course, by growing the popularity of these methods and also the availability of these methods, we have access to broad documentation of the models. And also there is so the researchers are proficient in using these techniques, because they have some computational skills, programming language skills, and because the models are computational fast, they are very accurate, and when there are analytical models that we can compare, they are better than that. We see the growing popularity of these models. Normally, the workflow, let's say, of this research can be divided into 3 steps. So on the first step, we have the data collection, and here an intermediate step we can have some data generation, and here using some numerical or experimental results. And on the second step, we have the development and training of the models. And in this step, I will say that we also have the validation of these machine learning models. And finally, the most interesting step will be to use these models to compare with some existing formulas, for instance, and developing some knowledge intuition into that. And finally, and this is not something that I've done, but we can apply to most complex problems, for instance, to design a frame in the case of fire, or something like this. I will show you some results of 2 cases. This is a collaboration with Professor Thomas Gernay from the Johns Hopkins University and his PhD student, Shi Tong. And we applied these machine learning models to 2 problems, to beams with slender sections in the case of fire. And this is the example, the same example that I showed in the beginning for the analytical models, the analytical methods. So the results that I will show are the same as the formulas that I presented, or the same case. But we also applied two columns with slender section in the case of fire. And here we know that our machine learning models are as good as our data. If we have wrong data, the machine learning models could be very good and predict very good things, but in the end they are wrong. So it's important to have high fidelity data, and a large amount of data is also necessary. In this case, we use the finite element method to generate the data, and to be sure that we have a good model or a good numerical model. In this case, we made, or in this case, Shi Tong made a comparison with some experimental results. And just as a curiosity, these experimental results come from the project where I was doing my PhD, and there was enabling us to develop this new formula. So this is all grouped together in the same context of steel structures in fire, steel structures with slender sections. One of the main, I will say, issues in this case is how do we encode our problem. So we start with the beam that has some geometry of the section and with some boundary conditions, and how can we encode this problem so that we can feed to the machine learning model and in the end have some predictions. In this case, we use some dimensional parameters for the section. For instance, in this case, you have the input number 1, which is the web slenderness, so the height of the web divided by its thickness. And we also use some other parameters, including the temperature here, and also some boundary conditions into this input. And this is important because there is some, I believe that it's recommended to have some engineering knowledge when we do this, because to train the models we need the data that could be representative of the case that we are studying, and also it's like I will use this example. For instance, in the web slenderness we have 2 groups here, but we know by the engineering knowledge that for this feature it's not so important for this problem, the web slenderness. So this looks very bad, but in the end it does not matter, so it is okay that we can use this. And for this case, it's recommended that we have some engineering knowledge. About the models that we used, and here I must say a note because I was more involved in the use of the neural networks, and Shitom was working with support vector regression, random forest, and polynomial regression. And it's important to get to know your algorithms. We have to know what we are applying, what we are using. For instance, in the case of the neural networks, and this is a big name, we need to tune the hyperparameters. And what is this? Really fast. Normally the neural networks have some architecture, so some number of layers, and we have to tune this in order to have the best response that we could get. Of course, it's also important to develop and train, for the development and training of the models, it's very important to have these computational resources, and for that I was lucky to obtain a research project which is only access to high-performance computers from the Rede Nacional de Computação Avançada. And of course, it's important to have some Linux skills and also some Python skills to develop all this, because you have to implement everything into these high-performance computers. And now the results. So you can see here, and these are the same charts that I showed in the beginning, and you can see here how the response is improved. So we started with this. During the PhD, it was possible to improve the answer of the response of beams in the case of fire, and we made a proposal that will be in the next revision of the Eurocode. But now, using these machine learning models, we could really reach a higher correlation between the data and the predictive model. And just 2 more slides on this. We also, so in these models, we trained the answer of the beam with bending moments on the ends. And in this case, we were trying to look if we could also use these models to a slightly different problem, although it's mechanical equivalent. And we can see that for a beam under 4-point bending moment, we could also use the machine learning models that we developed. And here you have a comparison of the Eurocode and the new version, or the new revision, our proposal. And you can see here that the artificial neural network could lead to good results. And although here the random forest, we start to see some decrease on the accuracy, maybe because the models are slightly overfit, but that's another question. And here also for the cantilever beam, also using the same model, so beams training with end moments, and we could apply this to a cantilever beam with some good results here. But of course, if we use some engineering knowledge, and here talking to structural engineers, it is a bit, we applied the C equals 0 to a cantilever beam, but just to demonstrate that it could improve the answer. So there is something there that we could explore in the future. So for the columns, and I have only this slide because this work was mainly done by Shitong and Professor Thomas. I was just involved in giving some comments on the data and more like that. But finally, we see that the same that we observed for the beams is observed in the case of the columns. So to conclude my presentation, I have some take-home message for you. The machine learning models are really fast and very accurate, and they are as good as our data can be. So it's important that we have high fidelity data, and there is some pre-processing here involved, and it's very important. It's a crucial step on that. Engineering knowledge is really recommended to reduce the gap between the developers of this technology, so the machine learning and data scientists working with this, and the technology appliers, it's our case. And it's good to get to know the machine learning model algorithms. I also made the exercise to think about some opportunities and also some challenge. And for the opportunities, it's interesting to think that these are really quick models. And I did not bring any information on how fast the models are, but if you have the model trained, it's like in calculation of in Excel. So you put the values, click on another cell, and the result is calculated. So these are really fast, and we could use this, and the intention is to bring back, or to come back to the beginning, is to use these models to generate new knowledge, see the influence of the parameters, and then include this influence in the analytical models. And this is important because of one challenge that I have just some minutes later. So I will say that this calculation model are also good for predicting response where we don't have analytical models. So for instance, the spalling of concrete or the non-uniform temperature in steel members, we can use these models. And because they are fast, and I'm not a specialist on this risk analysis, but as they are fast, we can take this risk analysis to the next step and analyze a lot of cases and focus on some critical ones, and this is an opportunity. But for the challenge, there is some, and I have to say this is a quite interesting point, because we need to find a common language to communicate with the machine learning developers. And this is a challenge. Sometimes it's not easy to speak the same language. And there is also some gray area in the usefulness and novelty of these models. Because the structural fire engineers and structural engineers community look to this, and they are not so, they don't understand so well right now what are the advantages of this. And also for the machine learning community, they look to this and say this is not something very, very new. But we need to persuade them by examples, such as I tried to do this morning. And finally, to conclude, there is some legal issues here and trustworthiness of these models, because I could apply them to design a frame, but then if the frame collapses for any reason, who is to blame? And this is important also to think about. Anyway, we can use these models in a preliminary design and then use finite element models, for instance, to confirm and to validate the design of the structure. So thank you very much, and this was...
Any question? Vitor? You're good.
Two very simple questions. One, does it make sense in your modeling to consider we have been doing some multi-hazard risks? So to introduce in this analysis that you are doing some influence or the influence of another type of risk. Imagine earthquakes and fire resistance. Does it make sense to introduce some weak links in the system to see how is the reaction in terms of these predictive models? And the other one is one I think it's very interesting, your work from the point of view of RISCO, because we are always aiming for international collaboration, and this is good for the research that we do here. And you have shown some examples like Johns Hopkins University. In that sense, as a researcher, does this, thinking about the next years, have you identified what you think it will be your stable international connections at this area and the access, for instance, something that referred important, the access to high performance computing in terms of allowing your research to reach the next step as you have mentioned? Do you have this clear idea what could be your partnerships, the ones that you already established and the ones that you are aiming to?
Yes, thank you for your two questions. So for the first one, it's an opportunity for sure. And I believe in the future we will see many developments. And you can think about that we have cars that are driving by themselves using artificial intelligence and machine learning. So if we could include some multi-hazard into these models, I don't see that as it will be difficult in the sense of difficulty, but surely possible.
But would it be interesting for
yes,
the
for sure.
construction?
For sure it will be interesting because it will answer a problem where we don't have analytical models, and this is one of the opportunities. And for the second question, of course, and this is one of the things that it's interesting because this partnership with Thomas started just to communicate some of the difficulties that we had with the numerical values, and then we jumped to, okay, I have a student working on machine learning models. At the same time I was studying this subject, and the opportunity come together and we are working. So I believe in the future, and I hope in the future too, so these type of collaborations could also happen with different research groups. Yes.
Good. Okay, thank you. Any other question? I have one very simple. Is it these tools can be used by common engineers or only by experts on this?
Yes, they can be used by common engineers. We can, and this is some next step that can be done next, because it can be implemented in some simple software that you can use, or even I've seen some machine learning models, because in the end these are mathematical models, they are formulas. And I've seen some implemented into Excel programs, so you just need to input the values and you have the answer. But to train and develop the models, that's another story.
Okay, thank you.
So, next speaker will be Celso Pinto. He is currently the head of the Coastal Monitoring and Risk Division of the Portuguese Environment Agency. His activity is focused in coastal erosion risks management, coastal monitoring, beach nursing or nourishment, and coastal protection strategies. So please, you can start, and your talk will be management and challenges of the Portuguese shoreline. Thank you very much.
A little bit different, I send it. But
You get it. Okay, this is one.
yes.
But it's related. So.
Thank you very much. I would like to thank the kind invitation that you made to the Portuguese Environment Agency. It's a central state government agency and we are the kind of people who do everything wrong. Because if we put sand on the beach, why are you putting sand on the beach? The sand will disappear, you're stupid. If you don't put sand on the beach, why didn't you put sand on the beach? There's a major storm and the beach disappeared. So, if something goes wrong, we are the people to blame. So, we have a lot of challenges and difficult tasks to manage coastal risks in Portugal. So basically, we have a simple geomorphological model for the coastline of Portugal. And the coastal areas are, of course, inherently dynamic, forced by meteorological, oceanographic, geomorphological, geology, and, of course, anthropic factors. So the type of the response of the system, of the coastal system, will depend on this pre-existing morphology. If we have a sandy coast, low-lying sandy coast, or if we have a rocky cliff. Of course, if there is no occupation, it may be some hazardness associated, but there are no people, there are no risks, okay? However, if the coastline is occupied, low-lying sandy coast, by small buildings, or large buildings, or rocky coast, of course, there will be risk to people and, of course, infrastructure located nearby the coastline. So, of course, in the absence of a clear understanding of coastal processes and therefore a reliable predictive tool, the default position is to assume that present-day coastal change will persist in the future. Of course, this will be exponentiated by climate change, namely, for example, sea level rise. Here we have several projections. Here in Portugal, where is that? Okay, we are using this scenario. It's developed by a colleague from the Lisbon University, and of course here are the extreme scenarios, for example, from the NOAA. Of course, and we have a recent report of the EPCC, who says coastal areas will see continued sea level rise throughout the 21st century, contributing to more frequent and severe coastal flooding in low-lying areas and coastal erosion. But, of course, this is not the only problem that we are facing with climate change. Changes in waves. This recent work published in Nature Climate Change shows that widespread ocean erosion, it was a global large-scale assessment worldwide, show that will be occurring mean annual significant changes in wave height, period, and shifts in wave direction under high emission scenario. And of course this will be problematic because these are the main drivers that induce coastal changes. However, these studies are yet to consider directional shifts in wave propagation, and this is a problem which have been shown to be the dominant driver of shoreline stability. However, recent work, for example, developed here in the Civil Department shows, for example, that in a local scale assessment using RCP 4.5 and 8.5 show that probably until the end of this century we will have less storms, but more intense, higher significant height, duration and power, but anti-clockwise rotation. So in this probably, mine. Great. Sorry for that. Okay, my mistake. Okay, perfect. Sorry for that. So probably we'll have lower long-shore sediment transport rates. So, okay, so probably this won't be so bad like we were expecting, but this is a lot of uncertainty, of course. So, basically, in the Portuguese coastline, we have to deal with 4 types of risks. Damages in coastal infrastructures, like groins, seawalls, rock outlet revetments, coastal erosion that can cause several damages to infrastructures, beach bars, restaurants, buildings, coastal flooding, that of course will affect coastal flooding, coastal overtopping, overwash in coastline, and of course rockfall. So how can we manage these risks? Okay, we have a strategic level for the long term that will set the policy. We have a tactical approach in the medium term that will set the management, and operational short term that will address execution of predefined management and policy options. So regarding policy, we have some national strategy, integrated coastal zone management document. We have a law that regulates soil use and territorial management. We have littoral working group report that define several guidelines and strategy and management options and protection measures, and redefine the global overview to manage coastal risks in Portugal. In the management, we have the shoreline management plans that sets clearly what kind of interventions and what type of interventions costs involved, in what places we need to act to mitigate coastal risks, and the littoral action plan that sets costs and prioritize the actions, and then the execution. We have several projects and studies, and of course coastal protection works that we can conduct to mitigate coastal risk. And I will focus basically on the projects and on the coastal protection works. And regarding in the middle, we have an important aspect, it's the monitoring. Because without data, without monitoring, we cannot make a proper management, we will not have the needed information to support decision making, to make also the projects and the coastal protection works. So basically, projects, studies that are, like Professor Carlos Coelho told before, made in order to solve problems that exist in the society, in a cooperation with the society. A study developed for the Portuguese Environment Agency, made by Universidade de Aveiro and the Civil Department, and F5 engineers, assessment of technical and economical viability of sand bypassing in Aveiro and Figueira da Foz. They made a lot of work, sediment budget assessment, wave and coastline modeling, and evaluation of sand bypass solutions. Why? So we can have the best information to basically decide what to do to face a real problem of erosion. And of course, cost-benefit analysis. Another study that is being made together with the National Laboratory of Civil Engineering, assessment of technical and economical viability of a detached breakwater. Once again, University of Aveiro and Civil Department is involved. Also developed wave and coastline monitoring, numerical and physical modeling for several breakwater configurations, and of course the cost-benefit analysis. Another project, like Professor Carlos Coelho referred before, Project Inca and Project Coast for Us. Also, cost-benefit analysis for short, medium and long-term horizons. Assessment of social and environmental impacts of climate change, adaptation options in order to reduce vulnerability of some coastal territories and increase the resilience. Coast for Us, application of the Coast software tool, and also, this is very important, provide to decision makers. So we are the decision makers, so we need the best and the most accurate information and the best scientific knowledge so we can make informed decisions based on evidence. And of course, we'll globally support our decision on the coast. What is solution A, it's solution B, it's solution C. So if we don't have the knowledge, if we don't have that kind of scientific knowledge, we cannot make a good decision on the coast. We will make mistakes for sure, but I think we're better now than we were 10 or 20 years before. And in terms of coastal interventions, like you know, Portugal is facing a severe threat of erosion. 45% of the low-lying sandy coast is under erosion, so basically we have almost 50% of low-lying sandy coast, and in that length of territory, 45% is facing erosion. Here we have some examples. We lost 13 square kilometers of land since the end of the 50s until now. And here we have, for example, long-term erosion here in Costa Nova and near Lisbon in Costa da Caparica. So this area disappeared. So, okay, what have we been doing since, for example, the 70s? First, the main strategy was focused on hard engineering, on seawalls, on grounds, on rock armor revetments, jetties in the harbor areas, and of course, they were made in the 70s, 80s, and in the 90s, and then they started to decrease because, okay, we protect small communities, fishermen villages, and these engineering works, they were effective in protecting local communities, but they did not manage to solve the global problem. The global problem is sediment deficit. So simultaneously, there was an increasing of beach nourishment. So hard engineering starts diminishing, and then we start making beach nourishment more and more, made by the environmental authorities, port authorities, and society police, for example, also made some kind of works. And while in hard engineering actions were made at the level of the consequences, beach nourishment was focused acting on the causes of the problem. So replacing or putting sand in a system that there is in sand starvation. So beach nourishment, also called soft engineering, where we use the sand dredged from the ports, that is dredged in navigation channels or older former deposits that are placed there from previous dredging works, but we can also go to the nearby continental shelf, and we have large areas that are here currently identified, and we have a good estimate and a good characterization of that area. So we can make beach nourishment in the near shore, put the sand in the water, so throwing the sand away, and put sand directly on the dry beach. Until now, we made almost 180 interventions since the 50s and put 42 million cubic meters of sand in the entire Portuguese coastline, from the north until and even in the south. And this is the magnitude of the volume of sand that we put in each project of beach nourishment. And just to show examples of, okay, so is this strategy being effective in some places? Because beach nourishment, one of the most important things is that we have to evaluate the lifetime and the performance and the behavior. So for that, we need, like I told before, monitoring. We need data and we need good scientific data. Okay, if you use, this is the coastline evolution south of Aveiro Inlet until Poço da Cruz, north of Mira Beach, and in the period of 12 years, we saw that the coastline, these bars show the graduation of erosion, extreme, severe, intense erosion, stable, or accreting. And we have these retreat rates for this area, and 75%, if we consider this scale, was under erosion. And like you see, these bars show Costa Nova under large erosion. But during this period, we only put about 300,000 cubic meters of sand in the area. No. Okay? So, per year. So 3 million in 12 years. Okay? But from 2008 and 2020, this completely changed. So, okay, we have still erosion here south of these drawings, of course, but it clearly changed the pattern. And now almost we decreased the erosion from 75% to 35% of erosion. Why? Because we put much more sand. Of course, there's other factors, but I just want to add the big picture that, of course, we're acting at the cause level. We're putting sand in a system that is in starvation. Another example, in Val do Lobo, in Algarve, different system, smaller waves, smaller wave periods, and here we put sand in 1998,
we're monitoring the beach width. That's a proxy that is used to evaluate the performance of the beach nourishment. Then the sand was lost, as expected. Then we did a second nourishment, lost again, and a third nourishment. And now at the moment we have almost 11 years without nourishing the beach, and we only will make a nourishment maybe from 2 or 3 years from now. So, okay, we were mitigating coastal erosion here clearly. So, if we continue this strategy, and considering that one of the adaptation measures, okay, we will protect based on beach nourishment, we can make some kind of adaptive coastal management. Okay, and we'll have time to adapt and to put in place more complex measures, like Professor Carlos Coelho told before. So, okay, we need to accommodate in some places. We are already doing that in some locations in Portugal, but they are more difficult. But the beach nourishment will give us that time. And of course, the more complex and the more difficult measures, planned retreat, abandon the coastline. Of course, it's more difficult because we have financial constraints, we have environmental, political constraints, social constraints. So, okay, but basically, if we continue doing this in some places maybe we have the needed time to put in action these more complex measures. And of course, to do this, we need cost-benefit analysis, for sure, because we cannot make these decisions without rigorous cost-benefit analysis. So, the last slide, challenges for the future. A lot, of course. So, like we spoke in previous presentations, how will we deal with large uncertainty? The intrinsic variability of the coastal system, it's very unpredictable. Climate change projection scenarios, and limitations, of course, of medium long-term projections of coastal models, of course. That's something that we have to do, and Professor Carlos told that before also. So how can we improve? Can we build a narrative, building with nature, and explain to the communities and explain to the politicians there is no zero risk, okay? If you live in this area, you are submitted to some kind of risk. And how can we put in place this narrative of saying we need to accommodate, we need to abandon, or we need to retreat? Our experience in Portugal is that this is very difficult to do. Okay, continue to stimulate a broad debate of exchange and information among the various actors involved in the planning, management, or use. Good examples are Project Inca and Cost for Us that work very good, that kind of broad debate. Engagement with politicians, stakeholders, and local communities, of course. And also, a problem that we have at the agency is how can we improve our communication skills to better deal with some kind of disbelief in science, that I think we all saw that during the pandemic. Mistrust in government policies, so we are the guys who make things always wrong. We are always wrong, we don't do anything good, and public administration. But also, how can we improve and we can educate social media? Because sometimes we only see negative news regarding the actions that we make and that we're making the same. Because how this is possible? We also make good things. So how can we improve this? And of course, like I told before, we have to improve the prediction capabilities of coastal models, and thing that is very important, compare monitoring data, real-time data, and data collected on the beach behavior with predicted scenarios in order to improve calibration and validation, to improve, of course, accuracy of those models. So, of course, for this, we have to maintain coastal monitoring programs in order to have this data to support these studies, and of course, for creating a causality link that advances understanding and allows for, of course, better prediction of those models. Thank you very much.
Thank you very much for your interesting, very interesting talk. Any questions? Yes, please.
Okay, very simple questions. A stupid one first. Where this sand for the beach nourishment comes from? Inland or offshore?
It comes from both spaces. For example,
and does it create an environmental problem or?
Yes, it must be made some kind of environmental impact assessment. In the past, it was not made because that's why we have a lot of problems. But sometimes we dredge, we make an agreement, a protocol with port authorities, and if the port needs to dredge in the navigation channel or in the inlet, after the environment assessment, okay, we split costs. Okay, you need to dredge, I need the sand, so let's get married. Basically, is that. And for example, in Algarve region, we have previous studies of offshore border areas so in the nearby continental shelf, and we have identification. For example, Val do Lobo, we go to the continental shelf and put the sand on the beach. So basically, two kinds of sources: dredging and also, of course, good quality sand without contaminants and compatible with the native beach sand.
The other question was for RISCO. It's important that we have researchers and a group here that can fit this win-win collaboration with the environmental agency in order to supply you what you have referred as the needed elements to improve the policy decisions. Of course, from the research unit point of view, it's important to have the examples of Cost for Us and INCA, of this financing that comes from the public instruments to be able to foster this collaboration between the research centers and APA. Have you identified the instruments, the financial instruments in, for instance, PT 2030, that can endorse this situation? This is it's one question I'd like to make from the point of view of a research unit. If there are instruments that allow the continuation of these good examples of collaboration between APA and the research center. There was POCUR in the past. I think there will be a similar one. We have heard yesterday that will be a similar one linked to sustainability in the PT 2030. So is this a target for our researchers and you?
The good news, and your question is excellent, because today I didn't have a meeting just I'm here because, and I have this meeting rescheduled to Monday, only to discuss what will be the next funding model of similar to POCUR. And of course, like this kind of projects, they were so successful. POCUR really supported and really like it because they are all connected with other actions of POCUR, and the funding, what they really like is this interconnection between projects that they all get together. So I'm pretty sure that in the next funding, we'll have, I think, more money for this kind of project, because the results, they are there. And POCUR, they really appreciate this kind of approach, and the cost benefit, for example, is something that, okay, we cannot live anymore without cost benefit analysis in the near shore, in the coastline. So I think that will be no problem.
And should this project, just a final question, because this is something that should these projects have a good communication strategy, because you have referred that you need to educate the media, but is that education also a lack of a good common strategy from these projects and from the environmental agency and from the research units that fail to communicate in the right way
I don't think the research units, I don't think they fail. I think they did their work very well, and they developed several public sessions, They provide really good involvement with the stakeholders, with the politicians. I think there will be maybe a more fail on our side on the communication of the Portuguese Environment Agency. It's very big, it's very dense structure, and sometimes it's difficult to achieve all the communication goals that we need. But I think sometimes the problem is not in the way how these research units or we make the communication. Sometimes I think there is not a predisposition of the social media and the society to receive this kind of information. Sometimes we invited them to this and they say, oh, we're not interested. Is this a good thing? So I won't go. Oh, is there a store? People killed? Okay, I will go there. Okay, I'm exaggerating, but I think we are on the right track. So we have to improve this communication. We have to continue with these public sessions involving all the stakeholders and engaging with citizens and politicians, and I think we'll get there.
Thank you very much.
Thank you.
So the last speaker will be Professor Miriam Lopes. She's Associate Professor at the Department of Environment and Planning of the University of Aveiro and a researcher at the Associate Laboratory Serão. Professor Miriam Lopes is a well-established researcher in environmental science and engineering, with focus on air pollution and health effects, air quality management, climate changes mitigation and adaptation, including nature-based solutions, environmental management and policies, too long list, urban sustainability, urban metabolism and circular economy, citizen behavior and engagement on environment policy and urban planning.
Thank
Please.
You. So, the long list.
Yes.
Thank you very much for the introduction. I also want to thank the organization of this event. It's an honor and also a responsibility because I'm a foreigner, and so I hope not be so boring for you. And as Professor Villarreal tell, I will talk about the impacts of climate change on building environment. And of course I will focus on the atmosphere. So I'm working in this research group. GEMAC is the Group on Emissions Modeling and Climate Change, and is part of the Department of Environment and Planning, and also Serão, Associate Laboratory. When we think about urban areas, we need to assume that cities are important contributors to climate change due to the emissions related with the urban activities and due to the fact that most of world population is living in urban areas. Particularly in Europe, almost 7% of inhabitants are living in cities, and they are contributing with 2/3 of greenhouse gas emissions. At the same time, urban areas are the areas are most exposed to the impacts of climate change. We already talked about coastal areas and other type of impacts, and particularly, okay, we have similar schemes, of course, but just to remember that most of the times people are thinking about the weather, extreme weather events, and of course assumes that the impacts are related with this. But as my colleagues already said before, part of this disaster risk is related with exposure. So we are living in places that maybe are not the right places, and under the current and particularly in future circumstances. For instance, this is the Dorian hurricane coming to Bahamas. It's a really nice place to be on vacations, but sometimes this can happen, and this becomes a problem. But part of this is related with vulnerability, and here we see different vulnerabilities. I will not talk about coastal areas, but just to say that when thinking about vulnerability, we are thinking also about things we choose to do. So in urban areas, we choose to live in specific environments, to build our cities in a specific way, and use the land use as we wish for our economic purposes, for our economic development, but also for other activities that are important. And this is particularly important in urban areas. And part of this is also related with behavior. So the way people behave also could have an important dimension when we think about disaster risk. So going to the beach and staying in the beach when we have this risk or hazard events increase these disaster risks. And some of the impacts we can find in urban areas are related with, for instance, with water scarcity, because we are living in areas that are so dense and we need to pump water to the cities, and sometimes we are facing some problems due to drought and to in specific seasons, and we are facing this problem nowadays. And sometimes due to the drought and to use of water and water reservoirs, sometimes we have also problems related with the salinity of these resources, water resources, and we have faults, and part of these faults are related with the events, but most of them are related to the fact that we are living in impervious surfaces, and most of the urbanized areas have a high rate of impervious surface that then don't allow the infiltration in the areas, and have these effects that Vijay mentioned before. And due to the high temperatures, for instance, during heat waves, we have this boom of bacteria and algae that could create some health risks and have huge impacts. We have the heat waves that affect people, particularly those people that have some elderly people, old people, and those that have already some diseases, some cardiovascular diseases that could be more affected. And particularly, these episodes can lead us to problems related with air pollution. So we are mostly focused on these parts, but also looking to the water balance and energy balance in urban environments, because they are really important to assess the impacts of climate change on air pollution. Another part of our research and our interest is to try to figure out how to implement and assess the impact or the benefits, I would say the cost benefits related with urban resilience strategies. So this is a kind of scheme that we could understand how to assess these resilience options. And of course, part of this is understanding the local climate, because sometimes when we look to these IPCC reports that are very useful, they give us the big perspective, the big picture, but sometimes we need to go to the local scale, to the urban areas, to the street canyons, to the road, and even to the building scale, in order to understand if these buildings are prepared to for these specific events, for strong winds or heat waves or other type of hazards. And then we need to identify vulnerabilities and risks and impacts, and think about options to adaptation options, but we need to evaluate and prioritize options, because as my previous colleague said, we cannot do everything because we have always a limited budget, so we need to make a kind of trade-off of options, and there is no zero risk, of course. And then implementing, monitoring and assessment, and then reviewing strategies. And I think part of the time we forgot to review, and sometimes we don't evaluate quite well. So this is part of the work we collectively at university, particularly in this research group in RISCO, people are doing quite well. So I bring here a case study of that we developed in the project, the project, where we try to assess and to implement some resilient options to improve the quality of Porto City. So we select this case study because Porto shows a rapid growth and urbanization rates in the recent years, and this also impacts on the urban heat island effect. And this is the area in Portugal, one of the areas, one of the cities with lower percentage of green and blue infrastructures or areas, a part of the river, of course. And in the future, we expect to have much more extreme weather events related with haze. And so, considering all these conditions, we try to assess how could we improve in the future the quality of city and the environment on city, and also in order to avoid air pollution issues related, particularly with ozone, PM10, and nitrous oxide that are the most common pollutants in Portugal, I would say. So, just to taking a look on the urban heat island effect, just to say that in fact, this is the type of transit of temperature when we make this transit from the suburban areas moving to the core city center and to the other part of the city. And we can realize that we have a variation in the temperature, this temperature profile. We assist to this temperature profile in the surface, but also in the atmosphere, in the environment around the city, in the urban canopy. And particularly, we can see here these thermal images that when we have these park areas, we have these latent heat fluxes that helps to cooler the city environment. And in the other hand, when we have these very high urbanized areas due to the anthropogenic heat, we have sensitive heat fluxes that increase the temperature in the atmosphere, in the urban environment itself, in the urban canopy. So during a heat wave, particularly in the summer when temperatures are quite high, what's happened is that in order to cooler the houses and buildings, we use this air conditioner that are transferring more energy, more heat to the atmosphere, and this will increase the heat in the atmosphere. So we are going in a loop where we are spending energy and we are causing more pollution and more heat and increasing the problem. So one way to solve this problem is using the nature-based solutions. There are different types of approaches, but particularly the use of vegetation or increasing green spaces, green poles, and also turn off the pavements more permeable to increase the filtration can help to solve some of these problems and have been adopted in some places around the world. And some of the benefits we can expect is an improvement on air quality, of course, a reduction on temperature, some positive socioeconomic impact. For instance, on savings on energy consumption. Also, it can promote urban compactation, so we can have a more heterogeneous land use, and this can promote more compactation. We can increase the biodiversity in urban environments, and this could have also some psychological effects on population, because it turns the environment more natural. We can have this contribution to flood control and to water management, particularly when we are talking about the circular economy and reusing water in urban environments, but we can find more other benefits. So in this case, we use, and in this project and other projects, we use this numerical approach, because to forecast the future, to assess scenarios, we need to model, as we saw before, and usually we extract information from the global circulation models. We extract these particularly meteorological informations related and associated with future climate scenarios, and then we use what we call a downscaling approach. We can use usually we use a dynamic downscaling approach, but we could use a statistical one. In our case, we always use a dynamic downscaling approach, because we want to take into account interaction with the land use and particular features that we found in a local space. So we can go from a global to a regional, or a more detailed regional area using what we call mesoclade models, and eventually we can go to some neighborhood, or even a specific street, or the interaction between the window and or the indoor and outdoor environment. And so we use some dispersion models accumulated with meteorological models to then assess the dispersion of pollutants and to understand the air quality in the area. In some cases, we have a wind tunnel where we perform some physical modeling, for instance, for specific geometries or infrastructures, in order to assess the impact of different configurations. And here I present some results for this particular case in Portugal, in Porto City. And you can see three different scenarios that we have modeled other scenarios, but I read those that looks more interesting for me. So those are differences. These graphs are plots of difference on the temperature between the nature-based solution scenarios and the baseline scenarios, that is the current situation. And you can see that we have obtained different results when we use, for instance, green roofs or white roofs and surfaces. So this is a very easy way, it's just painting things in white. And then the duplication of green areas in the parks. So we have a park, and we imagine that we can expand this park and duplicate the area. So as you can see, in different type of configurations, we can have different outputs. Here we have an average decrease in 0.5 degrees in the area plotted. So Porto is here, and then we have here a decrease in 1 degree. So if we cover all the urbanized area with green roofs, we get 0.5. If we just paint all the areas with white, we get a decrease on 1 degree. And here it's a more complex situation, because when we include green parts, we can have increase or decrease in temperatures, and this is due to some turbulence effects that vegetation can take place in the area. And here is the impact of these scenarios on the PM10 concentrations. And you can see here, this is the plume that is coming from this particular time of the day. And we have very different results using different configurations and different type of scenarios. But of course, here, in this case, adopting green areas looks that have better results than just putting green roofs. So what we can see is that we have some specific features that depends on the land use and the type of characteristics of the urban environment. This is from another project. In this case, we use a dike in Eindhoven. So this project on the lab is ongoing and it's almost finished. And we are focused on 3 different cities here, Temporary, Genova, and Eindhoven. And in particular for Eindhoven, we simulate this nature-based solution approach using in these boxes here, and these are related with green parts. And here we didn't have any green parts. This is the current situation. And you can see here the temperature in the baseline and the impact of the green parts. So this is the difference between the green parts and the baseline. And here are the difference on NOx to concentration. So in this case, we get reductions in both scenarios. This is just to say that nature-based solutions are important. They can increase the resilience of cities to extreme weather events under climate scenarios, but we need to assess this and we need to model, because there are no linear effects that and there isn't a kind of only solution for all situations. So thank you very much.
Yes, please.
Can I ask a question?
Sure.
Thank you very much. Really nice. I like this more than what you do than what I do. So I have many questions, but I'll ask only 2, and then maybe I can talk with you afterwards. First of all, have you managed to transform this into money? What I mean is, for example, you have very good solutions to try to decrease the temperature, but how is this basically might save us some funds in the future? For example, you showed very nice examples about the heat wave, and we know that so many people die every time there's a heat wave in Europe, right? So is it possible sometimes to convert this into an economic gain? Because we have less people in hospitals and we have less people dying. So, because a lot of times, at least when I do this for earthquakes, we always have to show the benefit cost analysis. How is the government going to save money in the future? That was just one question. And the other part is that I noticed that, for example, in a lot of the regulations from the European Union, they don't want any more like retrofit the building just because of earthquakes or do this specific measure just because of floods. They want something that's much more holistic. And I thought it was so interesting that basically with some of the interventions that you might have on the building might help not just, for example, the temperature, the quality of the air, or for example, flood risk, but could also help other stuff. And maybe people feel a little bit more encouraged to do some of these modifications.
Thank you very much, Vito, for your question. I really want to talk with you later because I understand that we have a lot of points in common. But yeah, from the cost-benefit analysis, I took too much time, and even so I tried to be shorter on this presentation. We used to close the cycle of this assessment, including also the impact on health. So the health benefits, usually we talk when trying to address the benefits, we think about the saving in health costs. Yeah. So by reducing air pollution, we are reducing the impact of air pollution in human health. And we have developed some integrated assessment tools that also consider the exposure to air pollution, the impacts of this, and on, for instance, hospital admissions, and also on days that people lose for work, and even on premature deaths, because this is also important. I don't know if you are aware about, but in all the World Health Organization estimates that every year 7 million people die due to air pollution. So this is the biggest cause of death, the natural cause of death, not related with diseases. So in fact, we do all this, and we use also neural networks, machine learning, because we plot different scenarios, and then we want to address what are the best options for emission reductions or for natural-based solutions, and use these narrow networks to optimize the solutions. Yes, but we are doing that.
Thank you very much.
This is the right point. We need to show to the authorities the cost.
Yeah.
So the cost, comparing the cost of implementation, because this is also important, and also try to address the externalities related with health benefits here.
Thank you very much.
Thank you. Romeo?
Just not quite a question, more of a global comment. Excellent presentation. I think we have so much in common because decarbonizing urban areas has also to do with buildings and also to do with obviously air quality. So we have a lot in common in this sense, decarbonizing urban areas. Just a quick question on if you have studies on the impact, obviously very driven to health issues, but buildings also have to be healthy. And if you talk about, for example, built heritage, are there any studies on the impact on the aging degradation effects of our buildings and not only over people?
We have developed some studies. In our research group, we focus the atmosphere from the regional scale, a continental scale, and to indoor air pollution. So in indoor studies, we are developing some projects nowadays. For instance, we were involved on this Aveiro Steam City project, and we are assessing using some devices, some microsensors. We are assessing air quality in the city, but in the Smith Green Homes in Bosch project, we measure indoors air quality, and we try to relate this to the type of configuration and location of buildings, the type of windows, the behavior of inhabitants related with cleaning activities and open windows or not. So those informations are really important, and then we can use this machine learning in order to plot and to forecast. Because this is important, particularly from emissions and so on. Because indoor environments are really important. People spend most of the time in indoor environments, 90% or something like that. So, and we have a lot of indoor emission sources from the type of materials that we are using, the paintings and the cleaning products. It's cooking and eating systems also. So this is a part of our concerns too.
Well, actually, we were talking here, and we have to challenge Cezanne to have like a B2B matchmaking event, because we have so much in common, and it can be more than climate change, it can be climate emergency.
Yes, for sure.
Thank you so much.
So,
thank you so much.
We reached the end, and I would like to thank all the speakers, the 5 speakers. I guess it was a very, very interesting panel on risk on the built environment. I especially want to thank the 2 speakers that came from outside our unit. Self-opinion and Miriam Lodge. We have seen in this last presentation that there are what were the benefits of inviting colleagues from other units outside our unit. So I'm sure.
I didn't mention that me and Carlos, we are working together right now
I know,
on the adaptation to climate change in the region of Aveiro. So this is also an important consulting.
But Carlos was also a member of CESAR. So thank you again.
So we'll have our coffee break now. Obviously, we're very delayed. Instead of 30 minutes, please let's take a 10-minute coffee break and come back at 11:40. Thank you. And online will be back in 10 minutes. Thank you very much.
Obrigado.
Eu estou hipervacinada, já estou ouvindo, já tenho que acho que
Só tenho duas horas, mas confio.
Eu também estou não, mas confio.
Não tenho que ficar 24 horas.
Então, vamos falar da atividade de programa para mim.
Olha, primeiro olhos para mim, depois eu fiquei para a rua.
Eu tenho que apanhar os olhos abertos aqui, já sei que quando o grupo é grande, os olhos piscam assim todos.
Pronto, prioridade é a senhora, não é? Exatamente.
E quando não dá, eu vou abaixo a cabeça, mas encontrei todos.
Isso não.
É isso que eu costumo fazer. Nem todos como velocidade, nem todos lá na sala. É difícil até todos olhar para mim, e os olhos abertos.
Eu vou chateá-los. Ana Souza está aí. Falta Filipe Tel. Falta só Filipe Tel. A Sousa está aí. Agora eu vou buscar
Terça-feira?
Sim, acho que sim.
Onde é que nos posicionamos?
Vamos ficar no assim, mas vamos tirar aqui Falta um. Estão a fazer testes. Ok. Lá se estraga a máquina. Preciso do Estamos impecáveis. Ao longo. Falta um. Provavelmente ele foi ali prestar declarações.
Prestar declarações parece mal.
A nossa polícia. Depois tiram mais que são um bocadinho. É verdade, eu estou a ser mais também, vocês estão todos com mais que fazer uma profissão. E o Covid já se
Eu também já não pode fazer nada, já o tenho.
Quer dizer, mal não faz mesmo. É que contaminação.
Eu digo assim que sim.
Fui do ar, António.
Acho que é difícil.
Fui do ar de próprio.
Sei que não era uma tocinha assim. Mas já dei negativo, embora isto seja incluída para fazer testes, mas eu fiz. A pessoa fica sempre mais descansada. Mas negativo com uma tosse. Somente com máscara.
É 10 minutos que
Eu tirei 10 slides. O meu, se eu ficar assustado, eu tirei 10. Os meus são XS. Isso não quer dizer nada. Às vezes é pior.
Pronto. Isso é mais um bocadinho. Mas agora não é Covid. Uma deve estar boa. Ora bem, vocês estão a começar. Ora, bom dia mais uma vez. Vamos então começar este segundo painel dedicado à sustentabilidade da construção. E, evidentemente, o meu primeiro agradecimento vai para todos os participantes do painel, que eu irei apresentar um a um, e vamos pedir-lhes a eles um grande esforço de contenção para terminarmos a hora indicada. E, portanto, vamos então iniciar este painel. The first intervention in this panel devoted to sustainability in construction is from one of our researchers and the teachers of the house of the Department of Civil Engineering, Inês Meireles. She has been dedicating to water management and water-related problems in construction, not only at the building level. And so she will tell us a little bit about its research in our RISCO research unit. Inês Meireles, por favor.
Thank you, Professor Vitor Ferreira. So I will, I'm sorry, I will give you a framework of sustainable water consumption in buildings today. And for nowadays, all of us know that rainfall is down to 7% of average in Portugal, and that 90% of our country is in severe or extreme drought nowadays. And this is limiting not only some water consumption, but also hydroelectricity production. So it is in the agenda now that we have to save water. And relating saving water with the Sustainable Development Goals, I wanted to tell you that we have to consume water sustainably, but if we are sustainable in consuming water, we will also optimize energy consumption, because we need energy to have water in our homes. And in addition, if we save water, we save energy, and we save or we minimize the emissions. So if we want to be accurate and have a model to quantify the water savings that we can have, we need data for that. I will not go into detail, we have to be fast today. But this is the model to know which are the water savings when we have a water efficiency solution in a house. Imagine rainwater harvesting, or an eco-efficient shower, or an eco-efficient tap. So any water efficient solution, and we can quantify which are the savings of water with that solution. In addition, if we know the amount of water that we are saving, we can also calculate the energy reduction due to that water efficiency measure. And in addition, we will also be able to calculate the emissions reduction due to that water efficiency solution. But the problem is, when we have a methodological approach, we need to have accurate data to feed that model. So we have several research questions that we need to reply to be able to have real numbers. So the first question is, how to take into account user behavior changes when a water efficiency measure is adopted. So imagine that you have different water taps, and what do we think? We think, okay, if I have a water tap that will reduce the flow rate in 70%, I will assume in my cost benefits scenarios that I will reduce the consumption in 70%. Actually, it was not what was observed. People changed their behavior when they used different devices. So it was observed in this study that even if we would reduce the flow rate in an amount, we would have the consumption lowering, but not as much as the flow rate. We even have some studies showing that people installed eco showers and actually the consumption increased. So we have to be very cautious. We have to understand how people behave, and we have to have technical solutions that are in fact sustainable. In this study, we also observed that male and female users were different in their behavior. So we also have to take this into account. In another study, we tried to reduce the lack of knowledge on the relation between the technical performance of eco-efficient showers and how these products affect user satisfaction. And what was observed in this study, it was a small study with 12 people, but they were with 10 different shower heads, And what we observed was that the majority of the users would not change their shower pattern even if we would change shower head. So what it means is that even if they had a more efficient shower head, the number of time or the amount of time that they would spend in the shower would be the same. So this was good, was different from the other, because in this situation, if we reduce flow rate, we will reduce the amount of water that is consumed. In the same study, we tried to make a correlation between the shower head technical characteristics in lab and also the replies of the users in terms of satisfaction. So if in fact these 10 shower heads were having the effect of saving water, why were some better for the users than others? So we found, like, this is just an example, that people like the first one and dislike the last one. So, and if we see, the temperature is more uniform in the first one, like circular, and in the other one, it is not. So if we are having the shower, we will have different feelings in the second one than in the first one. So people didn't know that this was like this. People just would say, this one I rate as the one I like, this one I rate as the one I dislike. Then a second question, how to know water consumption pattern and distribution in buildings. So we really need to know how water is being consumed. And to analyze this, we tried to see if there was an influence of air temperature on the consumption of hot and cold water. Because we know that for water, the hot water consumption is where we consume more energy, so we didn't want just to know how much water was consumed, but also the part that was hot water. So we've considered two different case studies, one in Belgium, where the water was heated at the level of the building, and one in Portugal, where the water was heated at the level of the dwelling. And was observed a dependence on the proportion of cold over hot water consumption with air temperature. Another study is trying to determine the end-user water consumption through artificial intelligence algorithms. It is just starting, but it will be with real data, very detailed, with 30 users in Aveiro. Question 3. How to determine the real water-related greenhouse gas emissions? So another study that had two different case studies, that is our building and also an hotel. So they have very different patterns of consumption, and we tried to determine the emissions or the minimization of emissions when saving water with efficient measures. And what was observed was that if we consider an average of consumption during all the year and also an average on the energy mix, we can have underestimations or overestimations of around 200%. So we have to be cautious on how to make our calculations. We know that water consumption varies along the year and also the energy mix. So we know that we have green energy in some parts of the year more than the others, in hydropower, with wind energy. So if we consider all of this average, we will have a huge error in our calculations. And the last question, in terms of green gas emissions, shouldn't we take into account the entire use of resources and not only the consumption of water per se? So if we think that we have a good solution to save water, but will it really save all the resources, or are we having one solution that is bad for the environment, but it seems good for saving water. So to try to reply to this question, we had two studies with the industry where was determined the environmental performance of WC elements using life cycle analysis. The first one for a prefabricated bathroom pod, and the second one for a prefabricated WC wall. And what was done was a comparative life cycle analysis where it compared the traditional solution with these innovative solutions in terms of water consumption, energy consumption, and resources consumption. So, like was said yesterday, we have to understand how to analyze LCA. So, for this situation, the study was comparable and was a comparative study, and it was with real data. So they were in Aveiro, both, and were collected all these base data to have the most real as we could comparison and fair comparison. So in conclusion, although water efficient measures are usually only focused on protecting this resource, sustainable water consumption in buildings should have an holistic perspective in order to maximize sustainability. Sustainable water consumption in buildings should explore the different dimensions of the problem, not only water, but also energy and the environment. Thank you.
A fast question. Anybody? Okay.
Very good job, I think. It's very few people doing that, and you really need modeling the water consumption in LCA. It's something new, and we need this. And I think they're doing an excellent job. But one question regarding our final: you don't think water has something to do with comfort, with well-being? So that's I think something that is so that are you thinking on that? Because I have an opinion that some strategies like this automatic faucets that close themselves, people hate it. It's not really good. So we should do something better. I don't know.
It's true. One thing that was very easy to shift was the dual flush cisterns, because they don't affect with your comfort. Yeah. So it is easy. You go to one button or the other, you are saving water and you are okay with that, because you do it on the right or on the left, it doesn't affect your feeling. Yeah. In terms, I think more than the faucets is the shower head. That is where you feel the comfort and everything, so it's where we need to focus, because in one sense is where you have more the satisfaction related to water, but also related to energy. So is where you have more emissions, where you have more money being used. So we really have to understand which are the standards that the people consider that is comfortable. So we don't need to go just for something that has a low flow rate, but we need to understand if people like it. And that's why the other study that I was showing was very important, because people were using that. It was in the UK, so they were with one shower head for each week, I think. So after 1 or 2 weeks, they would shift for another one, and they would say if they liked it or not. And they didn't know the technical characteristics, but it was very important, because you can have something that it seems to save water, but then you put it in your home, and after 1 day or 2, you say, no, I don't want it.
Yeah. Thank you.
Okay, thank you very much, Inês. Thank you for your... we have now the intervention of Guilherme Serão, who is one of our recent RISCO researchers. So we'll be working on the area of materials and sustainability, and you're telling us a little bit about the advanced materials and the sustainable construction. Thank you. Dan, for you.
So, thank you, Professor, for the kind introduction, and thank you for having me. As you may have heard yesterday, I'm one of the guys that was recently hired, so my presentation will be a little bit different, not much about results, but I will take this moment to share some ideas that we can work on it from here on. And as Carlos did, I also show you two pictures to start my presentation. One of an airplane of the Wright brothers, and a skyscraper of the same age, more or less, in New York. And all of us know that airplanes don't look nothing like this anymore. But if we do the same observation for construction, in many cases it's hard to spot any difference at all. So, but now we know that we need to reshape the way we relate to our building environment and the way we construct our building environment. And there is a growing number of reasons to do that, from shortage on the labor market, from stagnation of productivity, but without a doubt, one of the main factors propelling changes in construction is the need for more sustainable practices. And why sustainability is so important and so stressed in construction is, first of all, because of the size of the sector, that is massive, and also because it's a very resource and energy intensive sector that also produces a lot of wastes. I also plotted here the global average of a number of features, just to show you that in Portugal the scenario is more or less the same, even a little bit worse on material efficiency. So all of us need to rethink construction and to address a number of questions like when and how should we build, what resources should we employ, if we should employ a resource now or tomorrow for construction or for elsewhere, what do we get in return as a society when we exhaust a certain resource, and what happens next? Can we repurpose a certain building or infrastructure? Can we retrieve some elements and use it for another construction? Or we can easily sort it and recycle the materials at material level? And I think the answer to these questions, or a big portion of the answer to these questions, lie on advanced building materials. And here I define advanced building materials as every material that can outperform current benchmark solutions, either in terms of technical performance, social, environmental, or economic. So these are the difficult questions to be answered. But what can we do? We can spend our resources wisely. This should be our priority. And how can we do this? And to show you some examples, I bring this bridge in Amsterdam that could be flat, no problem there, the channel was small, but they intentionally designed it this way so it can work just under compression. And by doing this, they completely avoid the use of metallic reinforcement. So this per se is already a significant environmental gain. But what interests me here is not that, is the concept underneath, is to design adequate, rational, proportional design responses to the needs that we have. And we can do this at architectural level, but also at material level. If we add a facade and we plot the efforts on the facade, we see that there is no uniform distribution. So why should we use the same concrete from bottom up? Why should we use the same metallic reinforcement from the foundations to the top of the building? And so this is an area that interests me, and we can think of this concept not all just for efforts, but for shading, for lighting, for opacity, for ventilation. We need to address the needs of a certain building, of a certain institution with ad hoc responses, not with a uniformitized response. And you can tell me, this is unpractical at on-site. Yes, maybe. So that is why we need to engage with more efficient manufacturing methods and promote these methods. Can be either prefabrication or additive manufacture, manufacturing, but we should not restrict ourselves to see additive manufacturing just as this kind of cementitious extrusion type nozzle thing, but we can consider other techniques and other materials like metals, composites, ceramics, and so forth, so on. The other thing that we should consider, we should acknowledge that we might need to revise our current standards and to introduce some sort of performance criteria, because the architecture of our standards, the end result of that is that we are using the same concrete to fix this fence wall than we use in the foundation of the skyscraper that I showed in the first image. And from a material efficient perspective, this is completely nonsense. And the other thing that we should see on the particular case of cement is that the number of non-clinker materials that are allowed are very few, a handful of them. And this, in practice, what is resulting is this preventing a lot of secondary resources to re-enter in the value chain, and by doing that, to decrease the environmental impacts of construction. So we should do this to allow us to use what we have on our plate, let's say, like these guys used to do in Turkey. And we should do this because local secondary resources is more or less equivalent. If you start with the local secondary resources, we end up with sustainable building materials. You should take this with caution. We should not assume it. We should measure with the life cycling analysis, of course. But I took these two graphs, two images, to show the importance of transport. This is a life cycling analysis of concrete that should be a sustainable material, but the impact of transport is still considerable. And in a slightly different angle, a group of Brazilians did this, the graph on the right, that say, okay, we will use a waste material as main raw material, but how far can we transport this waste material without compromising the sustainability of the end product? And so they designed these influence areas maps that are quite interesting. And this has been more or less the basis of my core research. That is, in every location that I worked before, I look for what are the industrial waste streams, and then try to valorize them into building materials, different building materials. This is has been the core of my research. Other thing that we can do is to get inspired by nature. Natural systems have millions of years to evolve, so they are naturally efficient and naturally optimized. And we can take the example of the nature. These are the two most known examples, the sunflower and the pine cone, and try to mimic this mechanism into the built environment. And we can play with rigidity, with expansion coefficients, and I show these two conceptualizations. That is a bench that is triggered by humidity, and the second one is a shading device, shading infrastructure that is built with metal alloys that have different coefficient expansions. So when it's too hot, it curves and allows a little bit of air to come in, so cool down the temperature underneath. We ourselves can be a source of inspiration, and there are a lot of groups, research groups, that are looking into vascular networks for self-healing concrete. I'm not sure this is a great idea for all infrastructures, but maybe for hospitals, for essential infrastructure, it could be something that we should look into. Other thing that we should do is to stop and have a look around us, not to be too narrow on construction, and see what other industries are doing. Industries that are more research intensive than construction. And we should do this because no one is anymore building cars with a hammer. No one is predicting stock changes, fluctuations with the pen and the paper. And no one is profiling antibodies without intensive use of statistical tools. And I know that because it's the job of my wife over there. And so we should look at that and see what they are using, what they are their best practices. And we should try to import this best practice to construction and to design advanced building materials. But this will require from us an open heart to engage with disciplines that we are not comfortable with, from biology to chemistry to statistics. So we need to collaborate with others. This is my final message. We need to open our hearts to others and to engage with others. And if you share the same point of view, let's stay in touch, let's discuss, and I'm sure that we will find common ground to work together. So, thank you.
Any question on this?
Thank you for your presentations. I wonder, because on the beginning of sometimes, let me put it this way, you start saying that there is a potential to think differently about materials, and you give the example of the concrete. But you still talk as if you are creating new materials, and I wonder what is your experience in the reuse, because then you use the example, use what we have. What is your experience of taking this approach into the existing building stocks and the existing materials which we already have in the construction process, in the industry?
Okay,
applied?
if I understand your question, you are asking what is my main topic of research. I will use the expression of Professor Carmine used yesterday. Autocultivation is my first love. But I used to work always connected to projects, to specific projects related with mortars, concrete, and autocultivation. But now I have the chance and I have the willing to explore other materials. So I'm not restricting to cementitious-like materials, but I would like to explore others and to take them from the lab to real-scale applications. We have, myself personally, didn't have the chance to do it yet. I'm always working at small scale, but it's something that we can work on it to upscale the findings that we made in the meantime.
Thank you very much. We will now follow with another RISCO researcher, young RISCO researcher, Eduardo Roque, that has been working on, he finished his PhD recently with us, and has been working on not only on light steel framing, but on energy efficiency concerns about different kind of construction. So he will be giving us his experience on this research. Please, thank you very much.
Hello, good morning. Good morning, everyone. So I will be talking about a little bit about the opportunities of prefabricated construction system towards energy efficiency and sustainability. Well, a very trendy topic nowadays on the construction sector. It was the base of my PhD thesis, so I will also be supporting this presentation with some data that I collected in this process. Well, we know that over the past years, industrialized solutions have been gaining market share over more consolidated and traditional ways to build in Southern European countries. And the light steel framing, LSF, is an example of this new trend that has been gaining popularity with great potential for prefabrication. And we know that prefabricated systems can present a wide array of advantages over more consolidated and traditional systems, such as heavyweight construction systems. For instance, the speed of construction, the reduced water consumption, the lower construction and demolition waste production, and the economic construction for deprived regions in crisis. These are all topics that offer a clear answer to some of the biggest problems that the construction sector must face nowadays. Well, we also know that because it is not a traditional construction system in Southern European countries, the energy performance and thermal comfort of LSF buildings has not been so widely studied and discussed compared to more traditional construction systems, such as reinforced concrete and masonry buildings. And the comparison with buildings of common construction in this scope is also a theme on which the information is scarce. And this lack of information, this lack of characterization, how LSF buildings, how prefabricated buildings, how lightweight solutions behave in our climate, difficults obviously the achievement of high levels of energy performance and indoor thermal comfort. And this difficulty can lead to dissipation of the advantages of this system. Therefore, my PhD thesis has focused on analyze, describe and evaluate the indoor thermal environment, thermal comfort of energy performance of LSF residential buildings, and compare in the same line of study LSF buildings with common construction systems in reinforced concrete and masonry, this considering the Southern European context in terms of climate, in terms of habits. The main goal was to evaluate the advantages and abilities of LSF buildings and characterize their impact on the functional performance and ultimately contribute to a more sustainable, efficient and enlightened growth of this LSF construction system. And the goals were accomplished by a large and fairly robust experimental campaign. And this campaign was based on the construction and monitoring of 2 test cells. These test cells intend to be representative of a real compartment by their size, by the constructive solutions that were considered, and by the presence of elements such as windows and doors that resemble to a real constructive solution. Well, we know that although having the same U value, the walls and roofs of the test cells present very different dynamic thermal properties. The U value is a code requirement of the Portuguese energy performance, and the dynamic thermal properties are not referenced in our code. And despite being exactly the same in terms of code values, this difference in terms of dynamic thermal properties can make a very significant difference in terms of indoor thermal comfort and energy efficiency of these constructions. So the test cells were monitored during 1 year, and quantities such as air temperatures, heat fluxes and solar radiation were quantified. During this year, October 19 from September 2020, 4 experimental setups were considered in the test cells. And these setups intend to evaluate situations and scenarios typical of residential occupation in the test cells, considering the effects of that occupation in the indoor thermal environment and the requirements to maintain a comfortable indoor environment. These 4 setups, for instance, are free running conditions, then insulating the ground slab, mimicking, for instance, a heating pavement, simulation of internal gains inside the thermal environment to simulate the presence of human activity, and also the quantification of the energy consumption during the winter of these 2 test cells. In this presentation, I will present some results of 2 strategies, namely the free running conditions and the heating energy consumption. Well, in this graph, we can see 1 year of indoor air temperature fluctuation. In green line, we have the heavyweight test cells in reinforced concrete and masonry, and the blue line, we have the LSF test cell. We can see that the heavyweight construction is characterized by a greater stability in terms of indoor air temperature. On the other hand, the LSF test cell reveals an indoor thermal environment more susceptible to outdoor environmental conditions. And therefore, this test cell, the lightweight one, presents more expressive maximum and minimum indoor temperatures and higher amplitude, especially under more dynamic outdoor conditions, such as in the months of September and December. I've also run some comfort analysis, and this analysis retrieved that the percentage of time outside the comfort region, again in 1 year analysis, returns a similar scenario for both test cells. Although the LSF test cells approach the upper limit of comfort region in September, anticipating a possible overheating scenario. And this overheating scenario is very serious because in this case there are no internal gains, the climate was not so demanding, so if we shift to more demanding climates with internal gains, the overheating risk can be serious. The monthly magnitude of discomfort reveals a less favorable scenario for the LSF test cells in terms of magnitude of discomfort. Now, for another setup, the energy demand for heating in the test cells, it was simulated a typical Southern European intermittent heating strategy. We know that in Southern European countries, it's not typical to heat our houses 24 hours a day. Typically, we heat our houses from the end of the afternoon until bedtime. So this strategy was simulated during the winter and the energy consumption was quantified. Well, we have noticed that the rate of increase of indoor temperature until reaching the heating set point temperature and the operating pattern of the heating system varies notably from cell to cell. When the heating system starts operating, the interior temperature of the LSF cell registers a rapid increase compared to the traditional cell. And this quick response to the heating systems can be a relevant advantages in a context of intermittent residential use. And due to the slower response to the heating systems, the masonry and concrete test cell, the heating system, the established comfort temperature was not reached within 10 days of the monitoring period. So in these 10 days, the 18 degrees inside was not reached because of this slow response to the heating systems. In terms of energy consumption, there was a lower energy consumption in the LSF test cells in all months monitoring, ranging from almost 20% to 60%. In global terms, the traditional masonry and reinforced concrete test cell consumed 100 kilowatt hours. On the other end, the LSF almost half of this heating consumption. And therefore, in the context of mild climate, such as the Southern European countries, together with typical intermittent heating strategies, the advantage of the LSF constructive system during the heating season are highlighted. And when I speak LSF constructive system, I can expand this conclusion to prefabricated constructive solutions that are also lightweight in terms of thermal inertia. Well, in terms of main conclusions of this work, I can resume that prefabricated solutions in general and LSF buildings in particular are clearly consolidating in Southern European countries. And the trend of progression is accentuated as they respond to possible drawbacks of the most current constructive system. Therefore, it's imperative to understand LSF buildings. It's imperative to know how these buildings react in our climate. It's not reasonable to expect to adopt the same strategies to LSF buildings and prefabricated building solutions as we do in heavyweight constructive systems and expect the same results. That's not reasonable. Improving the capacity to manage LSF buildings' energy gains, solar gains or internal gains through an eventual increase in thermal inertia could be a central aspect in their efficient and sustainable adaptation to the Southern European climate context. And in my work, I've seen that simplified evaluation methodologies, such as the ones present in our energy efficient code, not supported by dynamic regimes or based on average monthly values, may represent important limitations in satisfactorily capturing the difference in terms of dynamic behavior of buildings with different levels of thermal inertia. And finally, the LSF construction system revealed important advantages over the currently most common construction system in terms of passive interior comfort and energy savings. However, it requires reflection and critical analysis when considered for more demanding climates than Aveiro, where these advantages can lose expression if not properly considered and adapted to the building. Many thanks for your attention.
Any questions? for Eduardo.
I can have one. Nice presentation. It's a nice approach to the problem. Do you have a long experience with this live steel frame systems in Portugal, or it's short? How many years?
In terms of research?
In market.
Well, in market, the LSF has been present almost the last decade, although the margin of progression has been accelerating over the last years. So it's present, it's growing, and is a serious alternative to more consolidated construction systems.
In many regions, like New Zealand and Canada, United States, they have reporting durability problems due to water infiltration on cavity. This changes everything, changes not only durability, but changes the thermal performance of the system. Did you have any report on that?
I do. We must consider that, in contrary to heavyweight constructive systems, the LSF and prefabricated building solutions are built with moisture-sensitive materials. Gypsum plasterboard are moisture-sensitive, OSB is, and obviously these construction systems require more attention to water management. And unfortunately, for instance in Portugal, we tend to apply the same strategies as heavyweight buildings that are building with non-moisture materials such as brick and concrete, because brick and concrete do not rot with water. Okay, it can stain, can degrade over time, but they not rot during 1 year. So I think it's possible, and the experience in the United States, Japan, Australia, New Zealand, where LSF buildings and wood frame buildings have been built for hundreds of years, and they are there and now are being retrofitted for more than 100 years, prove that this type of construction is feasible and is durable if the correct cautions are taken. Obviously, these systems have a different identity, and that identity must be respected.
The devil is in the details. What they did in the States, in Australia, is not what they are doing. I think it's a completely different approach. But I think it's an interesting point, Victor.
Okay.
But and you didn't see any infiltration on the cavities on your testing?
No, we have not. We have not. We have taken all the cautions to avoid that. Water-resistant membranes, correct detailing, and in order to flush water out of our building.
Okay. Thank you.
Thank you very much. I'm going to switch a little bit because I know Felipe has to leave to Porto in
Maybe I can start now.
Can start? So, agora vamos passar, so now we are going to move into our external invited interventions. One is it's from the University of Aveiro, Felipe Teles, that has been working now another research unit, which is GovCop, which we feel that we might have some interesting relations to explore, and so we invited Felipe to tell us a little bit what GovCop is doing and what he's been doing in terms of this research that could be interesting for the RISCO research unit to relate with. Thank you.
Thank you very much. Good morning. Thank you, Vitor, for inviting me and for giving me the opportunity to try to see how a social scientist can relate to the presentations you just made. So let's see if it works. And congratulations to RISCO for organizing this day with this topic. As you may have noticed over the last 5-10 years, the role of social sciences, in a broad sense, have slightly changed regarding the way it relates with other sciences. It used to be, and I saw that in some of the presentations, a kind of a helpful tool when you need to understand individual behaviors, social behaviors, choices, values, and some of my colleagues as social scientists, they tend to perform that role of providing information when engineers and other scientists need some help.
What I tried to say when I asked you to see how it changed is that we can see that nowadays social science is performing a different role. Rather than providing help, it's bringing framework to the challenges we all are facing in different fields of expertise. And the challenge, well, the first challenge is the fact that I have a huge title for this presentation, no slides, so don't worry. The huge title was Challenges for Sustainable Cities, which means everything. And what I'm trying to bring you is just a very brief overview of what we've been doing over there with GovCop here, but also an overview that recently I had the opportunity to do at the European level, since I'm in charge now of one thing called European Urban Research Association. And precisely at the Euro level, we had a high-level discussion with the European Commission on what are the main challenges cities are facing nowadays. Most of them relate to sustainability, as you will see, but I would say sustainability is a good overall concept to grasp all these concepts. I will do it in 4 minutes, so don't worry. The 30 seconds before that, just to tell you that we at the GovCop are engaged in several projects that could relate to what you are doing. Ecological footprint of Portuguese municipalities, circular economy of water, well, together with the Department of Environment, well, so many things. A project on nature-based solutions in cities, well, that touches really easily with the things you're doing, but from our side, we're looking at the policy, the governance arrangements, the public side of this kind of research. So let's go to the challenges. The policy mantra, you know, the things we always repeat about this regarding sustainability is the same everywhere overall Europe. New sustainability living, solutions based on circular practices, short value chains, issues not just only related to construction but also related to food, for instance, from farm to fork, small short value chains, clean energy, clean mobility, sustainable built environment. Well, the mantra is there, it influences behaviors, it influences policies, it has influenced financial incentives, and it is clearly influencing research. The main lesson we had the opportunity to explain to the European Commission was we need to avoid sectoral analysis and sectoral behaviors from a researcher and from an implementer perspective. So sectoral approaches were the used approach done by European Commission on energy, on technology, on collaborative arrangements, on sustainability as a climate or environmental issue solely, mobility, governance and economy, safety, even homeland security, as we know what's happening right now in the borders of Europe, and built environment. All those were used to be treated and considered as very silos of approaches towards sustainability. We must say that the major challenges are actually cross-thematic. The major challenges in urban environment relate to acceleration of problems, acceleration of climate change, of migrations, of the pandemic, of the economic crisis. They are more frequent, so the challenges and the problems occur more frequently. The second one is digitalization as a challenge. You know, smart golf, smart living, the problems with privacy, or privacy as the Americans say, data security, also related to IoT and the use in buildings of ICT technologies and those related to digitalization. The third one is diversity. With mobility, well, with acceleration and digitalization, we face diversity as a challenge. Diversity of preferences, of lifestyles. One of you said what people expect, how to value water. I think it was the value of water. Well, the diversity in preferences also translates, and we know that from all the social science surveys on behaviors and choices, that nowadays it's much more difficult to find patterns. The average is easy to calculate, as you know, but patterns of behavior. So people have more diverse choices, values, and behaviors, and that also affects some of the research you need to understand what to use. Modes of production, fourth challenge. Modes of production is much more related to my research area, which means policy, public policy modes of production, which is different from what we understand as modes of production. But it relates to the fact that we produce policies differently nowadays. We have the traditional hierarchic way of doing it, the state, local authorities, and regional authorities producing policies. But we also have, well, the private sector, the third sector, civil society engaged in producing common living, so policies together. This creates new ways of understanding how incentives for behavioral living in urban areas can be induced through traditional hierarchic administrative public administration policies, but also through individual and collective behavior, which brings new challenges also for urban living. Fifth challenge, the dissemination. The dissemination is something that we in universities know what it means. Policies disseminate. Best practices disseminate easily. Problems disseminate easily. So it brings the idea, or one challenge is the fact that we have to deal with this more globalized context of information, of knowledge, but also of the challenges this knowledge brings. And finally, the political stability is something that sounds a little bit far away from sustainability, but it's quite relevant. Political stability is a challenge nowadays in Europe. Political stability is about democracy and decision making also, and we know, I spoke about this 3 months ago with the European Commission. We didn't expect Ukraine to be as it is today, but it's one good example of how political stability may affect even sustainability issues. As we know, energy is highly dependent on that side of Europe. So a sixth challenge to end, to be very fast. This brings greater complexity to urban governance, to urban public policies, to urban living. 6 challenges. It means that we have a greater need nowadays in European cities, small, middle-sized, and large ones. Greater need for understanding the conditions for urban sustainability, which used to be very straightforward. We know what at least environmental sustainability would mean. Now it's much more complex to understand what is at stake. Second, we need policy coordination and avoid the silo approach, the typical silo approach to problems and to solutions. Third one, what we call alliance building strategies, or kind of a maintenance capacity of this overall urban system. So we need, through the anti-silo approach, to bring all the actors involved in this process together. Those responsible for the built environment, those responsible for the overall governance of the city, the citizens, the ones responsible for mobility, for energy, etc. So this maintenance capacity of the system is quite relevant for urban sustainability. So my final message, and I have 35 seconds, final message is, most of your questions, the questions you were addressing as research or problems or whatever, related to or dealt with one specific question, which is how people value something. The value of water, the value of heat, the value of well-being. And that should translate into the materials we use, the techniques we use, the options we do as a city. And I would say that is clearly one of the roles of, or one of the opportunities of bringing together this different expertise from political science, social science, economy, and other areas, urban planning, etc., that we have within our research center, and the expertise and questions you have that we also share. And probably one good lesson based on the lessons I was trying to summarize is, let's try and work together more often. Thank you very much.
I will make the questions so we can be faster. Because you're talking about this silo approach. We know how to develop and research on and mobilize industry into built environment sustainable solutions from the building level until the city level. What is usually lacking is because we feel that at the side of the policies and the mobilization of the regional or the central government policies, actions, we lack some experience there, of course. It's not our field of research, but we feel that it's important as a green public procurement induction measure that will stimulate not only economical activities but also research activities. What could be the role of this link, or if you feel that this could be the role of this link between the RISCO research unit and your social science, and not only that research unit GovCop,
Yeah,
if that
you just gave one example of how both research units would gain from this. We may have some expertise. I always say we don't know. We may have some expertise on how policies are created, stimulated, induced, changed, how to interact in this multi-level system of governance between local, regional, national, and European policy fields. So we may have that. However, we lack the message. To be more clear is difficult. So we may know the intricacies and the details and how to move around the governance systems, how they work, but we should do it to provide a specific message, to provide a specific change towards something. So we would need the expertise in this field, for instance, of built environment and others. And together the message would be more on a specific target and with a focus. The other way around, you have all the expertise, I would say the content, the suggestions for the policy. Our role there would be to add to that expertise and to provide the channel, the channel to change the policies. So I think that's one simple example.
That's our challenge for you.
One possible challenge.
And possible B2B matchmaking between our units, just to generate what can you do to improve this, because this is also our reply to our industry that needs to see their development come through someday. Thank you very much.
Thank you. Thank you.
We have a long partnership with Saint-Gobain Portugal, one of the companies, so we asked them to, and we know they are deeply involved in their sustainability strategy for 2030. So we asked Ana Souza, thank you very much for your presence here and to tell us a little bit about Saint-Gobain strategy for 2030 regarding sustainability and how can we relate as researchers and this research unit to that we have been engaging for more than 20 years with Saint-Gobain here in Aveiro. Thank you.
So good morning everyone. I'll do my best to be quick. I know everyone is hungry by now. So let's just take this off. Okay, so today I'm going to talk about Saint-Gobain's strategic plan for sustainability. I'm actually replacing Ana Lourenço from our sustainability team that couldn't join us today. I will do my best to answer any questions you have, but you have my email in the last slide. In case I don't know any answer, you can send me an email afterwards, and I will make sure that I get the answers you need from someone at Saint-Gobain. So, okay. Just a quick outline for the presentation. I will begin with a small introduction, where I will show you some key Saint-Gobain figures, also some background information on why sustainability has become such a pressing issue for us. Then I will state Saint-Gobain's purpose and commitments. We will go into the strategic plan for sustainability. Then a simple R&D case study of what we do here in Aveiro in terms of helping out reaching the sustainability targets Saint-Gobain needs to meet, and to wrap up the conclusions. So some key figures for Saint-Gobain. As I'm sure you all know, we are a multinational French company. Saint-Gobain's first job was to manufacture the glass for the Versailles Palace in France. So we have been around for many, many years, more than 350. Well, this is actually a group presentation I had from 2016, but the numbers are not far off. We are more than 170,000 employees worldwide, and we are present in many countries, around 66. In my case, for instance, I joined Saint-Gobain while I was living abroad in the United States. There I worked for Certainty, which is Saint-Gobain's North American brand for building products. And then when I had to move back to Portugal, I joined Aveiro, and I do mostly NPD, new product development for waterproofing and flooring. So, as one of the top 100 global innovators, it is clear for Saint-Gobain that R&D can play a crucial role in addressing the sustainability challenges we face today. Out of curiosity, 1 out of 4 products sold by Saint-Gobain today didn't exist 5 years ago. So we are clearly a company with a strong innovation mindset. The planet, we all know it's in distress, and we need to do more and do better. In particular, the construction sector, which accounts for 40% of the CO2 emissions. We also use a lot of resources, generate a lot of waste, and with the growing needs in raw materials, energy, and transportation, the challenge is to meet these growing needs while using less carbon and less resources. So our purpose is to act every day to make the world better and a more sustainable place to live. Our commitments are to use less carbon-intensive designs and materials, using less energy and using it more efficiently. For example, here in Saint-Gobain, Portugal, we have installed solar panels in Carregado, our Carregado facilities, and we are in the process of doing so in Aveiro. We also are committed to influence our network to decarbonize together, whether working with raw material suppliers and transportation, also finding options to sequester the carbon we emit, and we aim at reaching net zero carbon by 2050. So, Saint-Gobain developed a CO2 roadmap, let's say. And how did it come up with this? Roadmap? It used 3 steps, let's say. First, by assessing the business's position on sustainability. Second, by defining priorities and goals for 2025 and 2030. And then by also developing a plan of action. And to reach these intermediate milestones and also to set this plan in motion, it identified 5 domains mainly. The first one, to act more sustainably. The second, to offer more sustainable solutions. The third, to make the supply chain and operations more sustainable. Also to communicate and educate on sustainability. And finally, to promote more sustainable markets. So, for example, to reach the very ambitious goal of net zero carbon by 2050, we have set intermediate milestones, and by 2030, for instance, we must have a 49% reduction in CO2, and with this, we want to offer our clients the best low CO2 and the more sustainable solutions, and with this also enabling them to decarbonize their processes. A simple example of what we do here in Aveiro, in the R&D team, and the contribution we can give to this end. We are working on self-leveling screed, which is an improved product over a current self-leveling screed we have on the market with very good customer acceptance, flow, and we came up with a new product that allows, or that we were able to reduce the cement, use less water, using byproducts from other local industries, also very important, and we didn't compromise performance. This product is not in the market yet, so we are working with our sustainability team to get the official data for the CO2 emissions. So to wrap up quickly, two main ideas. Saint-Gobain is rolling out measures to support its roadmap towards carbon neutrality by setting these intermediate targets, and also R&D can play a crucial role or have a significant contribution towards meeting these targets, as we are a company with a clear innovation mindset. And that's it. Thank you.
Short presentation. We still have time for one question that you might want to place. Okay. So, I'll do it. No, I'll do it. Okay. Everyone must have a question. So, how do you feel in this strategy, in this sustainability strategy? We know that you have been cooperating. This last example that you gave with the flow is something that we are engaged here in RISCO in a collaboration with Aveiro in a pilot experiment. So we feel this collaboration to be very useful for us also, because it allows to keep this the focus of the RISCO research unit on something that can have an impact on economical activities and on the day life of cities. Do you feel that this sustainability strategy that Saint-Gobain has designed has in some way promotes or mobilizes this kind of relation with research centers and universities?
Yeah, I think these type of collaborations are crucial to meet these targets, and we work a lot with the Universidade de Aveiro and have seen great work coming out of these collaborations, and it's essential for us to have these synergies to create the best products and the more sustainable solutions possible to our customers, and then to reach these targets. And I think it's a great collaboration to keep for many, many years.
Okay, thank you.
Can I just maybe just add another question, Joanna? Obviously, the idea of incorporating their byproducts from other industries into new building components and materials is obviously very important. But do you feel that in the future that we'll be able, for example, when we have public contracts, private contracts, that we'll be kind of like obliged, like in the value chain of building and disconstructing and reusing this material, that we have to have some type of, I would say numbers in the future, that we have to, for example,
meet
certain targets in terms of incorporating construction demolition waste or reusing materials from other industries?
I think so. Actually, even internally, Saint-Gobain has also set ambitious targets, even for us, that we need to reach and to use in our products and in our designs. So I think the future will have to pass by that type of measures if we really want to be serious about this. And I think it's important that we are. It's a very serious issue. We will have to impose those targets, and everyone will have to apply to them. Yeah, I think so.
Thank you. Thank you. We have ended this morning session. I want to thank you all for your presence, and particularly to the panel, give us brilliant presentations. Also thanking the people on the live streaming that are accompanying this session since this morning. More than 60, I believe, people that are on live streaming watching us that have been registered. So it's a pleasure to have this event going on. We'll have now a break for lunchtime. We'll be returning for live streaming at 2:30, but I invite you all to come to lunch with us here in the University campus. We'll go as a group, and we'll try to return at 2:15 here, so we can have a little talk before starting at 2:30 with the live stream session for the last panel. The rector will be joining us in this last moment of the RISCO session, so I urge you to return here at 2:15. Thank you all for your participation.
Esse curso está presente no nosso vai ficar na caixa.
Yeah, exactly. So I have to go over it with
Não deixar, fica por trás. Pior. Não parecem os outros. Pois é. Querem tirar 5 segundos. Não esperem. Este Covid já se foi. Não quer tirar? Já não é para cá. 5, 6, 7. Obrigado.
Alguma fica bem.
E daí os dois ficarem abertos.
Baixava
So, good afternoon to all. Welcome after the lunch time. So now we start the third panel of this day, the last one for the presentation. And this panel is related with conservation and rehabilitation of the built environment. And the first talk will be delivered by Professor Unidade, entitled Rehabilitation, Sustainability and Circular Economy.
Hello, good afternoon to all. I will present this presentation on rehabilitation, sustainability and circular economy, trying to give an insight into what we have been doing, mostly in terms of materials, in this specific area of rehabilitation, which is linked, of course, there is no other way around, actually, so it's linked to sustainability and circular economy. So firstly, I would like to show that this is inevitable here in Aveiro. In terms of materials, we have adobe as our main material, so it's an earth-based material, but we also have what we called pão de açúcar walls, which are walls made from ceramics that were used for building these walls because they had no other use. So we are talking about circular economy already. And so in Aveiro, it is obvious that the materials had this input in terms of circular economy before, and they will have in the future. One of the first things that we started to study here was Roman mortars as well, which have ceramics, ceramic residue inside them. So this is not new. We are just picking this up in a different way. And I will try to show how in this specific area of building materials linked to rehabilitation, we're picking this up right now. Of course, we have dealt with each one of these three in our research, but I will talk specifically about some research projects that we have been doing from the beginning of RISCO until what we're doing now. So, circularly, and we have circular materials such as airline. Rehabilitation, sustainability and circular economy are circularly linked to our research, stakeholder society, and also we work in a circular way here at the university within our research unit, RISCO, with other departments of the university, and we are strengthening this link right now, and with local, national and international partners as well. A brief insight into this, and just looking at how we started here. One of the ways we started was working with a nearby municipality of Aveiro, and we published this book, which is online. We try to do this in this way, that everything is available to all. So you can check this out online, and it's called Traditional Techniques for Glazed Tile Application Facades. Going on from this, the last thing we've published online in this area is called Traditional Stone Construction Techniques in Cape Verde. This was just last year, and we are going to perform a workshop on this next month in Cape Verde itself for masons who want to learn this and who want to redo this kind of traditional stone construction techniques in Cape Verde. It's missing there at the moment. Talking about the more scientific research area, the Serão Restore project is ongoing. It's almost finishing. It's got a lot of lab work, so it's a little bit late due to the COVID situation. But we're working inside the university, for example, with the Geosciences department, also outside with the University of Porto, Faculty of Architecture, and with the National Laboratory for Civil Engineering. This project is based on early 20th century mortars, and we have a set of tools that we're using, scientific tools that we're using for this project, and the characterizing mortars from the theatre, Teatro Nacional São João in Porto, for example. And this is the sampling procedure. Some more mortars from this theatre. They are different because they are made in a distinct way, which is quite obvious from these pictures. And here they are. Some mortars from another big building in Porto, in Cabulhão, in 1914, with various interventions from then on. So it's quite not very easy because this building had lots and lots of interventions. Teatro Nacional São João had less. Some more samples where you can see the different mortars and we can actually, just looking at the mortars, we can look at the interventions quite obviously in some cases, like this one, for example. And what we can see, it's very delicate work, very much based on microscopy, on trying to find evidences of different materials. For example, distinguishing between ordinary Portland cement and natural cement from the beginning of the century is quite difficult. The only way we can do this is through these thin sections, and so this is a result from Teatro Nacional São João showing cement from the beginning of the century. And here, the sand from the theatre and the problem we have, the degradation problem we have in the theatre. Another ongoing project which has just started, almost started, last week with some visits, and we have quite a few people, some people in the department involved, but also another department, which is social sciences, which has been here. And this is work at various levels. And so the Historic Villages of Portugal and the Association of Architects from the centre. This project is on the historic villages, the 12 historic villages of central Portugal, and the input we can have in terms of these historic villages is not only giving guidelines, but giving guidelines in a specific way, incorporating issues such as sustainability, energy incorporation of materials, CO2 incorporation, circularity, but also checking out how they can behave better in a thermal way, how their indoor air quality can be improved, because there are indoor air quality problems, for example, due to the stone they're using, for one, and due to some solutions that have been put in place. And so it's quite a holistic way to look at how to intervene in these villages, or how to give guidelines. Just looking at them, we can see vegetation, and we can incorporate new trends that have been brought about by time itself. We can look at thermal comfort and see how we can use single glaze and old solutions and still have thermal comfort. We can look at water and heating solutions, but we can improve them by using the past knowledge. We can look at renders, and I like this particularly, and we can look at tradition, but also incorporate innovation. And we can, and we should, and we will have social awareness. And for the intervention, we will listen to the people of the villages and to their needs. This is a picture of something we did in Busaco with students during a summer course, and so this is a way of having an intervention with the support of the community, and we have a prison community working there as well. On another scale, a project we have at the moment, which is taking some time to actually start, involves all of these universities. It's an Erasmus Plus, but also it involves the Department of Environment here at the university. And it's basically based on how we can work all of these sustainable development goals in various issues in terms of the different universities. Another project that is in rehabilitation, but towards the market, the 4.0 market, is with various universities also in Portugal and with ICOPN. So very clearly we'll have an output which will be put into practice, which is very, very much what we want here. And a project that I am enjoying very much, and have a colleague also working on this in the area of the water area, is Building Women, which is a social project that we're also working on and giving some workshops on as how women can actually intervene at home in rehabilitation actions themselves, or have their own company in this area, which is something that is possible. And so this is, of course, an area which links rehabilitation, sustainability, circular economy, society, and on the various local, national and international levels. Thank you very much.
Thank you. I think we have time for one question. Please.
Thank you, Anna. Excellent presentation. I really enjoyed it. The question is, this virtuous triangle that you just showed me between rehabilitation, sustainability, circular economy, where do we start exactly?
We can start at turning points, I guess. I think we have to incorporate it. We can start at turning point and incorporate the three. I don't have an exact answer for you, I'm sorry.
No.
It's just incorporating three, just looking at it as a whole.
No, thank you very much.
Okay, so to the second presentation given by António Fevereiro, researcher from RISCO, new researcher also being with us for a long time, and the presentation is entitled Thermal and Energy Rehabilitation Challenges for the Building Stock, New Approaches and Old Problems.
Well, thank you for the presentation and good afternoon to everyone. Today I'm going to talk about thermal and energy rehabilitation challenges of the building stock, new approach to old problems. And in this sense, I would like to start with the old problems. As everyone knows, the building sector is responsible for consuming higher levels of energy, of final energy, around 40% of the total energy considering all sectors. And in this sense, I would like to highlight that more than 7 buildings in 10 are energy inefficiency, and approximately 9% of the buildings standing today will still be in use in 2015, and 15 million of European citizens are living in energy poverty conditions. Focusing the energy poverty in Europe, the global scenario is not an encouraging scenario, and looking to the Portuguese reality, we are the fourth country with the higher level of energy poverty. And these alarming values are constantly highlighted with several impactant newspapers reports. The building stock is not prepared to provide citizens well-being conditions and thermal comfort. In this sense, it is absolutely urgent an intervention on this level, reducing the energy demand in buildings, but without compromising the thermal comfort for citizens. And the ambition is clear: more energy saving in the building sector, lower energy bills for citizens, healthier homes and offices, leading to improved productivity. And in this sense, the question is what is needed to fulfill these ambitions. The building renovation stands out as the only option to improve Europeans' inefficient and polluting buildings, with massive benefits to the environmental and healthy as well as society. Translating these last slides into numbers, the reality previously presented, a clear tendency is observed with an exponential increase of CO2 emissions and energy, and we have to stop these trends, to invert these trends, to work in decarbonization, and this work is really aligned with United Nations Sustainable Development Goals, namely the goal number 7. Well, moving on, new approaches are needed to overcome these limitations of the present, of the standard regulations that we follow. They are based on steady-state methods, as illustrated in the red line. We can observe the error related to the uncertainty present in the parameters like geometry, materials, lighting, user actions, weather, and these differences leads to high differences regarding the design of the building behavior and what we get in reality. Well, thus we have to work to reduce this performance gap. A current strategy that has been implemented in recent thermal codes in some European countries, in fact, they are starting using dynamic simulation based approach, and it's good, it's really good, because a good reduction in the uncertainties were already achieved. We are moving from the red line to the yellow line. However, the question is, this reduction is sufficient to mitigate the performance gap between the real behavior and simulated data to achieve the United Nations goals? Well, this approach, in fact, can be further optimized to reduce the uncertainties to the minimum possible values as possible, toward accurate models that correctly represent the real behavior of the buildings when they are designed and simulated. And this approach could be used in rehabilitation actions or in new buildings for upgraded design solutions. Well, focusing in the case of energy and thermal rehabilitation, this approach follows a specific methodology. The first step consists in the dynamic model definition. In this case, the software Energy Plus was used. The second step consists in the building monitoring, air temperature, air tightness, solar radiation, all the parameters that affect the performance of the building. In the third step, this information is programmed and inputted data in the optimizer. Then a list of parameters containing all the uncertainties are defined with a specific range, okay, with limits, lower limit and the higher limit. And these parameters could be discrete variables or continuous. For example, if we are talking about, for example, the insulation thickness, we can optimize from 3 to 4 centimeters, for example. Or if you use discrete variables, we can define different solutions for windows or for the glass or for another parameter that we can go there and substitute and use solution A, B, or C, or other different solutions. Well, then the optimizer will instruct the software, in this case the Energy Plus, reading the monitoring data, comparing this data with simulated data, adjusting the parameters, values, the limits, until to achieve convergence. In this case, the objective function used was the root square error to minimize the difference between the real and the monitoring data. Moving on for the different application and results, now I'm going to present 3 case studies and 4 different challenges. The first one was a demonstrated for the rehabilitation, and the second one and the third one was used as demonstrated for new building designs. Well, regarding the performance gap challenge, we developed a methodology for calibration numerical models, and this methodology was tested in this building, the SIGFANU building. This building is located here in front of the civil department. In this building, this building has two compartments with the same space, same geometry and orientation, and has one room that was installed a solution containing PCMs, and the other space with no PCM. And the methodology and first challenge was tested there. The second challenge was the optimization of building features using phase change materials and different values of air change rates in the building. Now, looking for the results and taking into account the first challenges, The model was calibrated, attaining an excellent GOF, a good of fitness of 3.19, with small difference between the real and simulated data. The objective function in this case was the reduction of the real and the simulated data. The second challenge, well, in this case, the ventilation system and the PCM melting point were optimized, and a reduction of 34% in the overheating rate was attained only by adjusting these two parameters. Okay, we can use this methodology, this algorithm, to optimize the operation conditions and the systems. Now, regarding the challenge number 3, and now in respect to new buildings and design phase, well, 2 tiny houses were constructed at the University of Aveiro, in the other part of the campus. They have equal geometry in those area, equivalent envelope and solar orientation to be compared. The constructive solution consists of a light steel frame solution that was already presented, this kind of systems in the presentation of Eduardo. And this type of construction system has a high risk of overheating as a major weaknesses. Well, for the definition of the envelope construction solutions, and taking into account that the goal of this work was the development of a novel constructive solution containing facade materials in the core, the optimized was used with the goals of the selection of the melting point, to optimize the PCM position into the construction solution, and combining different solutions with the different melting points of PCM in the same constructive solution, and of course also to optimize the ventilation rate of the building. Well, regarding the results, a reduction in the overheating rate of 24% was obtained, and the heating demand was reduced in 54%. Always comparing the enhanced solution with the reference one. Now, moving on for the last challenge, this concept can also be used to optimize the passive elements of the buildings by changing the architectural blueprints. In this case, 3 different houses located in Brazil in 3 different bioclimatic zones, ZB1, ZB2 and ZB3, were optimized, these 3 houses. This work results of a PhD thesis of an invited researcher from Brazil. The parameters here optimized were the windows area and the shading dimensions, the overhangs in this case, and the objective functions were the energy consumption and the thermal discomfort rates. Well, regarding the obtained results, a reduction of the windows area in some orientation was very high, okay? So it is needed to adapt the dimensions of the window solutions to get the best results in terms of energy efficiency. On average, in all buildings, the windows area was reduced 40%, and the overhangs was increased the dimension, especially in the facades that are that are oriented to solar radiations, to higher solar radiations. Well, as a conclusion and summarizing this presentation, the old problems are well known: the energy inefficiency, the energy poverty, and also the thermal discomforts presented in the most of the European buildings. And another problem is the standard regulations that are following steady state methods in the calculation, in the energy calculation, and the limitations and the uncertainties presented in these based methods is really high. So therefore, accurate models are absolutely needed, and it should be a legislation obligation and new approach based on the advanced tools and advanced models with the dynamic simulation and optimization should be incentivized. Okay, Thank you for your attention.
Thank you. We have time for a question. Please.
Thank you, Antonio. Can you share with us your opinion on the following? Well, I think that we have codes, particularized for thermal codes and for energy codes. I think the codes that we have are codes that basically make buildings comply with minimum requirements. So they're not obviously very ambitious. And we have another problem that couples to this, which is basically we design buildings and we don't test our solutions. We don't monitor our solutions to understand if the building is really performing as we expected. And I think it's a combination of both. I'd like your comment on this, because we have regulations to fulfill minimum requirements. That's what we have. We're not more ambitious than this. But people should think that the building should surpass or exceed a certain normal level of performance. And at the same time, some monitoring or some testing to say, okay, you've got it right, you don't got it right, you have to correct this and that. And I think that's really important, because that gives credibility to, obviously, to all these type of tools that you've just shown.
Yes, it's true. In fact, our regulation, it's a closed regulation, and it's just defined parameters that we have to attain. For example, to get a minimum value for walls, U value for the walls, or we have to define some renewable energy in the building. But the regulation doesn't define how the building will work, join together all these small parameters or all these limitations. We do this, but here in dynamic simulation and as researchers, but we have to improve this and to give this to society to be used in a real context. Well, the second question, it's really important, because, for example, in the other building, only by adjusting two parameters, the air ventilation and the DPCM melting point, we could have a reduction in the overheating at almost 40%. For example, in this room, if we optimize the lighting and the ventilation, probably we don't need, for example, a system for cooling or for heating, or we cannot optimize and decrease the energy needs if the building is correctly designed and tested, of course.
Okay, thank you, Tony. I think you have a lot of work to do. You have a lot of work to do in some rooms of this building. Next speaker will be Raquel Matos, which is a PhD student of the department. It's almost near middle of PhD. He's the energizer for the PhD students in units. So thank you, Raquel, for presenting the
I'd like to thank you for the invitation for this presentation. As Professor Hugo said, I'm a PhD student, and this presentation is about the part of my PhD that has already been done. So it is entitled as Applying Computer Science to Sustainable Asset Management and Refurbishment. My supervisors are Professor Fernando Rodrigues, Professor Hugo Rodrigues, and Professor Aníbal Costa. This first part of the work aims to develop a building conditions strategy supported not only in key performance indicators, quantitative indicators, but also in other technologies like machine learning and life cycle assessment methodology. And those methodologies will be linked up by BIM, Building Information Modeling. This theme came around because the Portuguese building stock has grown during the 20th century, and according to statistics, there has always been a higher percentage of new construction compared with rehabilitation. And So our Portuguese building stock is very aged and degraded. But the lack of preventive maintenance plans and lack of information about the facilities are also factors that promote the inappropriate and costly maintenance and rehabilitation actions. Another factor that accelerates the building degradation is the climate changes. And in this matter, the construction sector is facing really serious challenge because it's suffering pressures to increase quality, but at the same time reducing costs and resource consuming, and at the same time also reducing energy. As I said, the architecture, engineering, construction and operation sector is composed by aged and degraded buildings, buildings with lack of comfort and many deficiencies, and these deficiencies call upon maintenance and rehabilitation actions. But to be efficient, these actions must be defined by a building condition assessment strategy, and this strategy must be supported by indicators. In this case, we are studying key performance indicators, but also other technologies like digitalization, like photogrammetry and laser scanning, and algorithms of machine learning. On the other hand, on the left, this sector is also a big contributor to environment impacts. So we foresee a great potential to attain the sustainable development. And that's why this sector is suffering big pressures from the United Nations and the European Union. And this is the reason why we explore life cycle assessment in this work. In the final, a building information modeling as a multidisciplinary and collaborative methodology will not only gather those methodologies but also automate them. So far, a building condition assessment strategy has been studied and it has already been possible to figure out that there are lots of indicators with no categorization and also indicators, almost no indicators as calibration models. In a case study, building inspections were possible to be made with resource of laser scanning and photogrammetry. And besides that, the degradation modeling based on machine learning was also performed to achieve life cycle condition trends and to predict the building degradation. In the regard of life cycle assessment, which is the next step of this work, a comparison of some LCA softwares were performed, and also a study about the building life cycle assessment analysis for building life cycle phases were also carried out. As for building information modeling, the building modeling was already done, and the parametric information related to the maintenance priorities were also integrated in the model. To validate this study, two departments of this university, of Aveiro University, were defined as case studies, and this motivation was based of being a large sample of buildings with different users, with different ages. The facilities has different requirements, and there are lots of deficiencies, and these deficiencies call upon maintenance, and these maintenance actions are expensive. But there is lack of statistics and report of difficulties, so there was a need to apply a questionnaire. The questionnaire was performed in last December and this January 2022, and was directed for facility managers of higher education institutions of Portugal, all the country. We obtained 19 responses represented in the map, and the data collected were related to their personal difficulties in the building inspections, difficulties in facility management of this building stock, And it was also asked about the preference on specific parameters to be then included in the key performance indicator that has been studied. This questionnaire were done based on a 9-point scale to be then analyzed by an analytical hierarchic process. Within this research, I've already, with my supervisors of course, we published 3 papers on national conferences, 2 papers in international conferences, and 3 papers in international journals. And the main contribution of this work is to promote the facilities work properly, decrease of the environment impacts, and to ensure that damage are recorded by an automated system based on BIM. In relation to the other output that we can obtain by this work is that this work can let us to obtain a more fast building adaptation using more affordable, reusable and sustainable materials to respond to other service demands, namely in case of the travel times. And as for future developments, a life cycle analysis for maintenance and rehabilitation actions must be also accomplished, a cost-benefit analysis and the integration of those methodologies into a BIM platform, a BIM methodology, and the application to a case study as well as its validation are important tasks to be accomplished too. Thank you very much.
Thank you, Raquel. Time for questions. Okay.
Oh, I can have it.
I can have it. I'm not escaping without the question.
Thank you, Raquel, for the presentation. Highly pressured by your supervisors, I understand. The question is simple. Obviously, it's really interesting, obviously, to have a case study in the house. It really helps. But these buildings are very singular in the sense that they are not common construction or residential construction. I see that if we get this right here with these type of buildings, then this can basically pass on to what we would say more common residential buildings, for example, or multi-residential buildings. So you think that what you're developing then can be passed on to the common building stock in a more simpler way, perhaps, because these are unique buildings in this sense.
Yes, in this case, the case study of this work, the proposed, is building institutions, academic building institutions. This is our case study, and what Professor said is true. So that's why I want to reproduce this for other institutions, not to apply just to our Aveiro University. But after this work being developed, I would like to reproduce also to residential buildings because it's possible, and the work just have to be adapted, but it's perfectly possible. So yes.
Okay, thank you. So the next presenter opens me the doors of Batalha Monastery 8 years ago, gave me the keys, and had the opportunity to open the monument to engineers, geophysics, and many other people to study the monument. This is Dr. Joaquim Rui, the director of the Batalha Monastery. And thank you for joining us.
Obrigado. Antes de mais, muito obrigado. Cumprimento a todos. Sou o professor Vítor Ferreira, conhecemos a hora do almoço, muito gosto de conhecê-lo. E ao meu caro Rodrigues, muito obrigado pelo convite. Vou falar em português, não porque o meu inglês é brilhante e fluente, só por isso. Acho que estamos em Portugal, não é? Devemos daquela velha tradição, mas não dá para falar em inglês, peço desculpa por isso. Esta história que eu vou contar na introdução pode não ter sido bem assim, mas convém que vocês a tomem como verdadeira, para o interesse da minha apresentação. Até os anos 90, os astrónomos, saberão isso melhor que eu, deparavam-se no espaço com uma zona de negrume. E é evidente que tentavam, com os potentes telescópios terrestres, observar a zona e não encontravam nada. Quando depois lançaram o Hubble, alguém mais teimoso e mais curioso orientou o Hubble para essa zona negra e, na realidade, o que descobriram foi uma imensidão de galáxias de todos os feitios e de todas as idades. Ora, isto serve para, de algum modo, vos colocar também, é como uma metáfora no que diz respeito à investigação. E eu que estou de fora, não sou investigador, sou só professor de História do ensino secundário, de algum modo, e diretor do monumento, de algum modo, há zonas negras na investigação que necessitam de ser observadas. Essa é a primeira coisa que eu, quando entrei para o mosteiro, com evidência, me foi colocado. E é necessário, em primeiro lugar, penso eu, utilizar os telescópios mais inovadores na procura do desconhecido. E depois é fundamental, em segundo lugar, sermos sensíveis e termos a vontade de nos instalarmos um pouco da perspectiva habitual e orientar o nosso olhar para essas zonas desconhecidas ou mesmo para as suas margens. E quanto mais não seja, e permitam-me esta manifestação de imodéstia, tem sido esse o meu papel como diretor. É motivar, estar aberto à investigação e, portanto, que de algum modo o monumento pode suscitar em diferentes dinâmicas, em diferentes áreas. Ora, o olhar instalado no que diz respeito aos monumentos é aquele que continua a focar exclusivamente na sua história, na história da sua arquitetura, na história da arte, na história do seu acervo e por aí adiante. E, portanto, quando na realidade temos instrumentos que permitem analisar noutras dimensões, com grande profundidade. Não direi que são dimensões mais importantes, mas a verdade é que são dimensões que possibilitam enriquecer o conhecimento do monumento e ter dele uma visão mais global. E como são dimensões investigatórias que não se baseiam apenas na história do monumento, no seu passado, mas analisam e avaliam o que presentemente está, acabam por dar um contributo muito importante na monitorização e, portanto, na preservação do monumento e na sua melhor salvaguarda. E mais, como esta investigação, como bem sabem, tem, melhor que ninguém, tem tendência a utilizar métodos e instrumentos em constante inovação, o estudo dos monumentos acaba normalmente por estimular o trabalho colaborativo, o trabalho interdisciplinar de várias ciências, bem como permitir a inovação na conjugação dos métodos de pesquisa. E, na realidade, o que eu pretendo com esta em minha intervenção, e agradeço já aos meus colegas de painel que deram todos 2 minutos ou 3 para eu agora estar um pouco mais, é que dar-vos de uma forma despretensiosa, sem entrar em domínios técnicos cuja complexidade me ultrapassa completamente, devo dizer com toda a humildade, quero mostrar-vos alguns projetos de colaboração, projetos de investigação colaborativos, que de algum modo se integram na temática deste painel e que vão ao encontro dos desafios que sempre se lança na investigação sobre o património construído. Na verdade, o que eu quero quase subliminarmente é sensibilizá-los para uma investigação orientada para o património construído, neste caso é património monumental, tendo a certeza que há muitas potencialidades e que há muitas zonas negras para orientar os instrumentos, os telescópios. E gostaria de vos, rapidamente, dentro do possível, evidenciar 6 projetos estruturados que temos tido ao longo destes anos. projeto de estudos de patologias da pedra, avaliação de comportamentos estruturais e monitorização, o estudo epigráfico do túmulo de Dom João e a tradução crítica do latim, enfim, noutra área já da investigação propriamente das ciências humanas, estudo da cor na capela do fundador, levantamento e inventariação das gárgulas batalhinas. O Mosteiro da Batalha tem o maior conjunto funicular de gárgulas que necessitavam ser inventariadas e estudadas, ainda tem que ser alvo de um projeto mais intenso de investigação, e o estudo geofísico do Mosteiro da Batalha, que nos ligou desde cedo à Universidade de Aveiro, através do Departamento de Geociências, com o professor Sérão Matias, e a monitorização de CO2. O primeiro projeto foi a que nos trouxe ao conhecimento com o engenheiro Rodrigues e através do Departamento de Engenharia da STG, do Politécnico de Leiria. Começou com a consciência de que, quando cheguei ao serviço, não havia nenhuma colaboração, nenhuma investigação, nenhum estudo que enquadrasse a instituição de ensino superior mais próxima de nós, que está a 8 km. E isso fez-me, de algum modo, fiquei perplexo, porque senti que nem do nosso lado, nem do lado das engenharias de Leiria, havia qualquer interesse num estudo de monumento que estava pronto a ser estudado sobre esse ponto de vista. Estruturas, de monitorização das patologias e por aí adiante. E, portanto, esse contacto com três professores do IP, do Departamento de Engenharia, o professor Rodrigues, Florino Gaspar e Luísa Gonçalves, acabaram por nos trazer aqui 3 mestrados, precisamente em 3 áreas de investigação no âmbito desta temática. O levantamento das patologias do capelo fundador, mestrado sobre a monitorização das vibrações ambientais no Mosteiro da Batalha, porque, como sabem, o Mosteiro da Batalha situa-se sobranceiro a uma encosta onde passa a IC2, cheia de carros pesados, e que a construção da autoestrada ao lado não veio não veio diminuir, porque tem que se pagar e, portanto, os caminhões continuam a passar por aqui. E a nossa dúvida era se realmente as trepidações eram evidentes, se afetavam com alguma evidência o edifício. Felizmente, demonstrou-se que até por aí não há grande perigo. E, finalmente, outra tese, a avaliação do comportamento estrutural da capela do fundador, que realmente são estudos também que não estão feitos naquele momento e que é imperativo fazê-los em todas as salas daquele conjunto monumental. Até para sabermos onde intervir, onde fazer já intervenções atempadas, digamos assim. E, portanto, este projeto consolidou-se também numa publicação que saiu na altura, também em algum tipo de monitorização. Esta sala, onde o antigo refeitório, é uma sala ainda com uma meia abóbada de berço, mas a nervura central está a preocupar-nos porque as juntas entre as pedras atingiam 5 centímetros, de vez em quando caía caliça. Isso é uma preocupação evidente quando temos esse tipo de algum modo, movimento, e, portanto, foram colocados sensores. Exatamente, Paulo, peço desculpa, e esses sensores, portanto, permitiram monitorização de algum tipo de instabilidade, parece que também não se verifica, felizmente. Enfim, noutros espaços do monumento, isso se calhar não é tão linear. E, portanto, há aqui um percurso de investigação, que de algum modo, e também de estudo, que de algum modo acabou por enquadrar e ter alguns frutos. Entretanto, uma área interessante também é o facto de nós termos na Capela Fundadora um dos túmulos mais importantes da nossa tumulária medieval. O túmulo conjunto de Dom João I e Dona Filipa de Lencastre. Por incrível que pareça, ninguém se tinha dedicado, por um lado, ao estudo epigráfico, ao estudo das inscrições, nem à tradução do latim para o português. E, portanto, aí, numa parceria também com a Universidade de Coimbra, acabámos por fazer esse estudo, que está concluído e iremos publicar, e, obviamente, esse estudo também, a professora a investigadora Filipa Avelar acabou por ter que fotografar todas as inscrições, ver algumas com os infravermelhos e, portanto, utilizando métodos um pouco mais avançados nesse estudo epigráfico, deixando de parte o estudo convencional, académico, das ciências humanas, de se limitar a fazer algumas produções da escrita e, portanto, há aqui um envolvimento mais profundo com as novas tecnologias e com novas áreas de investigação. Apesar de ser, enfim, um estudo que não converge exatamente para aquilo que estamos a falar aqui, acaba também por ter a sua potencialidade nesse campo. Este estudo é um estudo muito importante porque, na realidade, a capela do fundador são visíveis os vestígios de policromia, mas também ninguém tinha colocado o seu olhar e a sua investigação para o estudo da policromia. O que é que estava pintado na origem nesta capela? E, portanto, juntou-se aqui também num projeto colaborativo coordenado pela investigadora Joana Ramoa, do Instituto de História da Arte, conjuntamente com o Laboratório Hércules, com o Instituto Português de Heráldica e também com o Politécnico de Leiria, o Departamento de Engenharia, acabaram por fazer uma investigação aprofundada utilizando vários métodos, obviamente, que vocês conhecem. De tal modo que também teve o interesse da National Geographic Magazine e que foi toda a sala digitalizada e de algum modo recomposto numa primeira abordagem aquilo que seria a cor inicial, todos os túmulos e até parte da capela. É evidente que estas cores são um pouco fluorescentes, não seria bem assim, mas evidentemente este dourado está demasiado dourado, enfim. Mas de qualquer modo, como podem ver, há aqui uma ampla margem de campo para investigação. Esta investigação tem que ser mais aprofundada. Nós não conseguimos tirar amostras, nem houve possibilidade de tirar amostras todas as abóbadas da capela, todas as colunas, para saber até que ponto realmente aquela capela na origem estaria toda ou só parcialmente pintada. Bom, é um estudo interessantíssimo. Podem ver também um pequeno vídeo no National Geographic em que mostra como está e ao mesmo tempo mostra esta aproximação à decomposição original da capela. Portanto, isto é um projeto que tem que continuar a avançar, assim haja financiamento. Também, eventualmente, todas estas abóbadas eram pintadas, como encontramos ainda alguns monumentos, e os próprios, todos os túmulos seguramente eram, porque aqui as amostras são claras e inequívocas, não deixam aso para dúvidas quanto a esta cor aqui existente. De algum modo, portanto, temos uma investigação que utiliza as novas tecnologias, mas ao mesmo tempo nos reconduz a uma ambiência que nós desconhecíamos. Portanto, há aqui um contexto interessantíssimo de investigação a ter em conta. Enfim, este é um pouco um projeto que também tem que necessariamente continuar. Temos o maior conjunto de gárgulas e a professora Patrícia Alho, investigadora, está a fazer a sua inventariação e necessariamente este projeto e está, portanto, a fotografar todas as gárgulas, mas o ideal será, nem todas chegam com facilidade, será utilizar drone e digitalizá-las por completo. Portanto, é um projeto que tem futuro também neste âmbito. E também, no fundo, agora está-se a ver com muito mais conhecimento quais são a cronologia das gárgulas, a que tiveram intervenção no século XIX, a que já não estão perfeitamente como eram na sua origem, e aquelas que são mesmo do século XIX. Portanto, esse estudo essa inventariação está quase concluída, mas falta também aprofundar esta análise. E então, este é o que nos leva à ligação com a Universidade de Aveiro, desde o início, porque um jovem doutorado era também vereador do município da Batalha, e, portanto, essa ligação afetiva, jovem doutorado nas geociências, que estava a doutorar-se, acabou por trazer o seu departamento a investigar e a fazer uma análise mais profunda do monumento. E, portanto, a novidade foi internacionalmente reconhecida deste projeto foi que eles utilizaram 3 métodos e, portanto, depois conciliaram os 3 métodos no conhecimento do monumento. tomografia sísmica, métodos de sustentabilidade elétrica e o georradar. E foi é essa inovação que aqui paramos, penso eu, que vocês conhecerão melhor que eu, pelo menos a ter em conta pela proporção que isto teve, que foi inovador. E, portanto, hoje o Mosteiro da Batalha é, sob esse ponto de vista, o mais bem conhecido de todos os monumentos nacionais. E há coisas interessantes, por exemplo, sabemos que 2/3 da igreja estão, aquelas grandes colunas que suportam a nave central e toda a igreja, estão bem ancoradas, vão até à pedra, a 4 metros, mas o terço da igreja, à entrada, foi construído sobre areia. E é precisamente aí que está uma ruptura estrutural, foi, digamos, evidenciada pelo terremoto de 1755 e que foi bem verificada com o terremoto de terra de 1969. Há ali uma ruptura estrutural que tem que ser monitorizada. E contamos muito com a Inês, que vai fazer um doutoramento que foi aprovado naquela bolsa que é da GPC, na bolsa de doutoramentos que o Ministério da Cultura e a minha Direção-Geral acabaram por contemplar, cerca de 40 investigadores, e o projeto da Inês acabou por estar contemplado nessa seleção. Enfim, vimos coisas interessantes, como é que as colunas foram feitas, como é que as paredes são feitas, o que é que está por baixo daqueles pisos, os túmulos que ali estavam, mais ou menos desconhecido, aquelas anomalias que correspondem a túmulos de várias personalidades. Sabemos hoje onde é que esteve o túmulo inicial de Dona Filipa de Lencastre, graças a esse estudo. Enfim, são depois contributos para a investigação histórica em geral que terão maior ou menor interesse. Enfim, as publicações necessárias. Depois a Câmara e a DGPC também contribuíram para a publicação em português deste estudo Anatomia do Mosteiro e, portanto, também o reconhecimento internacional deste trabalho, né, da conjugação de vários métodos. E, finalmente, esta perspectiva que agora será continuidade numa colaboração com o Departamento de Engenharia, através da intermediação do professor Rodrigues, na continuidade da monitorização do Mosteiro da Batalha que bem precisamos. Aqui vou fazer uma pausa antes de terminar, que se calhar já estou a amassar demais. É que, vocês como sabem, está aqui claramente expresso, é um dos conceitos fundamentais da sustentabilidade. Ora, nada pior para um excelente conceito do que o seu uso excessivo e a sua banalização, porque na realidade corremos o risco de usar tão displicentemente que deixa de ter sentido para nós. Isso é um perigo. Bom, isto é utilizado, a sustentabilidade em tudo, comida sustentável, gastronomia sustentável, turismo sustentável, é tudo sustentável hoje em dia. É um chavão que acaba por integrar de tal modo que acaba por perder. Ora, se há conceito que continua a ter, é essencial ter em conta neste contexto e no contexto do património, obviamente. Mas costumo evidenciar o seguinte, nos anos 80, quando pediram ao Italo Calvino que dessas suas impressões sobre o que é que seria a literatura no próximo milénio, o Italo Calvino acabou por, de uma forma mais simples possível, chamar a nossa atenção para a sustentabilidade e para a nossa responsabilidade do futuro. E ele diz simplesmente: iremos ao encontro do próximo milénio, isto refere-se à literatura, mas refere-se a tudo, objetivamente ao património, sem esperar encontrar nele nada mais do que aquilo que seremos capazes de levar. Isto é, a nossa responsabilidade atual perante o futuro. E, deixem-me dizer, o património não é coisa do passado, o património é coisa do futuro. É uma herança que recebemos e que temos que saber transmiti-la íntegra, ou sem a desvirtuar, ou sem preservá-la. Isto são banalidades, mas a verdade é que temos que ter consciência disso. E por isso termino com aquilo que nos deixa alguma esperança no futuro. É um projeto simplicíssimo que temos com o agrupamento de escolas da Batalha, com os alunos 7º, 8º e 9º ano, que é apenas a monitorização do SO2 nas envolvências do mosteiro. E, portanto, estes alunos têm aqui um projeto humano, vão monitorizando sistematicamente essa carga de dióxido de carbono. É evidente que à frente do mosteiro junto à estrada é maior, há outras situações onde praticamente não deve ser considerada, mas é isto também nos lança nesta perspectiva de futuros jovens investigadores que poderão ser vossos alunos no futuro e que ao mesmo tempo nos deixam a esperança que o património está conhecido e salvaguardado pelas novas gerações. Portanto, era com esta mensagem final que eu vos queria deixar. Muito obrigado.
Muito obrigado. Vamos ter para uma questão. Duas. Não vejo ninguém. Força, força.
Também é mais um comentário propriamente uma questão, mas pronto, deixava-lhe assim uma pergunta, se calhar a resposta muito rápida no final. Assinalar, de facto, esta excelente apresentação no sentido de aponto que o mosteiro faz parte do nosso imaginário em Portugal e, portanto, é talvez os mais emblemáticos, tem esta preocupação de se ligar às entidades de investigação e manter um programa de investigação ativo à volta do mosteiro. Isso é uma prova de sustentabilidade para o futuro e portanto, queria de facto dar aqui nota e foi excelente ter visto esta evolução dos trabalhos e perceber que termina também com um que envolve particularmente aqui a nossa unidade de investigação, o risco, nesta última louça que a Inês nos vai ganhar, que nos vai permitir construir esta relação, que se pretende que este seja um primeiro passo e que venha, pelo menos penso que o Departamento, nas suas várias competências, terá certamente contributos que poderão aqui consolidar esta relação e de alguma forma contribuir para, digamos, este propósito que eu senti que a direção do mosteiro tem de estimular a investigação como forma até de, digamos, procurar evidenciar este património único que o mosteiro da Batalha representa. E, portanto, a pergunta que evidentemente deixava é se, de facto, isto é um propósito que é assumido pela direção do mosteiro, da sua pessoa, enquanto programa para o futuro, e se podemos contar com esta abertura em relação à nossa unidade de investigação e estes trabalhos em volta de uma obra tão importante e tão relevante para a nossa identidade cultural.
Sim, muito obrigado. Já, sem dúvida, porque este é também dos meus grandes desafios, se eu continuar como diretor, é manter e potenciar todas estas ligações dinâmicas de investigação nestas áreas. E, portanto, obviamente, para nós, a parceria com a Universidade de Aveiro é fundamental e está bem presente naquilo que vai ser o nosso plano de gestão no futuro. Neste e noutros níveis, até só do ponto de vista só cultural, há pouco falámos na possibilidade de termos aqui uma exposição do Mosteiro da Batalha aqui na Universidade de Aveiro. E, portanto, isto para nós é prioritário e continuaremos a 1000% a tentar também a vossa colaboração, e agradecemos muito estes anos.
Muito obrigado.
Muito obrigado. For the last presentation of the session, we are more than on time. I want to call Paulo Duns from the Physics Department and from the other research unit from the University of Aveiro, I3N, that will give a presentation on the use of optical sensors for structural health monitoring. And I know that we have been working for the last 15 years, I think, monitoring the building, so I would say that it's more than good to see your presentation.
Okay. So good afternoon, everybody. Thank you, Hugo. First of all, I want to thank this unit for the invitation to be here, especially Hugo and Romeo. I will talk a little bit about optical fiber sensors for structural monitoring, and especially the work that we have been doing together between RISCO and the Department of Civil Engineering and the Physics Department. So I will start a little bit in a very fast way to talk about the optical fiber sensors advantages. I will show you some of the sensors that we have developed over the years and the applications, and I will focus mainly on 4 case studies, which are telecommunication towers, the water reservoir of the university, the Unidade church, and the Universidade. In all of this work, these 4 works are researchers from here involved. Aveiro, which was my PhD co-supervisor, and of course Hugo, Serão, fevereiro, Evento was a master's degree at the time, the project of Aveiro, and some more. Okay, why should we use optical fiber sensors? Over the years, we have noticed that the electronic devices have some drawbacks of fragility, instability, consistent feedback, they are magnetic or perceptual. They are very fragile to humidity and water environmentals. They are electrical active, and they have a high visual impact, which is very important, especially in the monitoring of installation construction. On the other end, in the optical fiber sensor, we have multiple advantages. They are robust, they are immune to electromagnetic interference. They have the ability to be multiplexed. This is in the same optical fiber cable, we can put several independent sensors. They are accurate, they have small size, lightweight. They can use because in the case of optical fiber sensors from silica fiber, they are immune to corrosive or explosive environments. They just use light inside the fiber, nothing electrical inside, so yeah, they are safe. They can go into temperatures higher than 1000 degrees. Because they work between them at the speed of light, they are automatically synchronized for model analysis, for instance. No electrical signal at the measuring point. For historical construction is also an advantage because they reduce the risk of electrical fires. And they have very low visual impact, as you can see here. This is just an optical fiber. Okay? So, at I3R and the physics department, we have developed lots of sensors over the years. Especially for structural monitoring, we have special best ones. They are accelerometers, uniaxial, biaxial. We have pressure sensors, we have liquid level for concrete curing, for humidity, strain, based on different technologies like fiber vibratings, fiber interferometers, intensity, silica fiber, polymerical fiber, and so on. Okay, we have been using this kind of devices in the monitoring of different structures, tests in the physics department, in mobile towers, water reservoir, here at the Aveiro, the published footbridge. I think that's one of the first works that we have done. Then the Universidade of Aveiro, the church, in the monastery, we have done some tests. I think this one was made right here in the department in Aveiro. This one also, humidity over 1 year. Some pooling of the concrete, the steel bar inside the concrete to see the displacement between them. So we have lots of different applications. Now I will focus in some specific cases. This one was a contract that we have made, I think 2 years ago with the North company to monitor, to make a study around the 2 towers. Well, they have 1 tower that already presented us a very large inclination. They want to replace it, but they want to test it before replacement, some reinforcement solutions. So, the first we have divided in 3 phases. First, we made measurements in the damaged tower. This is it. You can see a slight inclination about this side. Okay. Then they applied a reinforcement solution. We made some measurements again, and then they replaced the tower with another tower, a new one, placed it next to it, and we made again new measurements. You can see here the built tower. This is from one side and the other side. There are structures here with many people over the day here, so it's a very dangerous situation here. This is the sensor that we put there on the top. This is an optical fiber accelerometer, but it has several types of advantages. In this case, we put on the same optical fiber, we put 9 FPGs. Inside here, there are 9 sensors inside. We can use the relationship between a pair of FPGs to measure the acceleration between each axis. And with this sensor, we can measure the tilt of the tower, the inclination, the amplitude of the oscillations, the direction, the number of it along some predetermined time, temperature, and the natural frequency of the tower. And we needed to correlate this with some wind parameters, so we bought 2 anemometers, so we place them on the tower to measure wind speed, gusts, and wind direction. Okay. This is the schematic of the setup. We have the tower here. We just put our sensor on the top of the tower. And then we have an optical fiber. And the Nosh company connected one optical fiber from the sensor to here, the university. The tower was 16 kilometers away from this point. They connected one special fiber for us from there to here. To the technical services, to our laboratory here at the physics department in the front of this building, and all the measurements were made from here. From the University of Aveiro, from our lab to the sensor itself, there is just an optical fiber, and nothing electrical is from this point on. Okay? The computer was connected to the internet, so we can make all the measurements and see in real time with the mobile phone what's happening at that time. So this is the anemometers that we put there, one over here, another over here, to measure the wind speed and the gusts. Here are some results. You can see that in phase 1, where with the damaged tower, the oscillations were very high, even for very low wind speeds. With the reinforcement solution, they decrease, so it's better, and it's even better with the rejoinder. Another interest parameter that you measured was the range of the oscillation of the tower. And in the first case, in the first and the second case, the oscillations of the tower were always in a different direction from the wind speed. That's not only. As you can see here, this is the average wind speed. This is during, I think, 3 months. And the oscillations were always inside this direction. With the reinforcement solution was not better in this case, but then with the new tower, the movement of the range is wider, it's better, and it's always within the direction of the wind. Related to the natural frequencies, there was an increase with the reinforcement solution, and even an increase with the river solution. Not a very significant increase, but with the reinforcement solution, the new tower, the mass was higher. So that means that the rigidity of the structure was also higher, which is better. In the Aveiro University reservoir, we made a remote study as well. This is the structure that is 100 meters from here. And we made all the measurements also, but in this case from the Institute of Telecommunications, which is in the other side of the university campus. The sensor was very similar to the other one, but it has only 4 FPGs, rather to 2 directions. In this case, we put also a seismograph on the top to compare the first measurements, and then we could measure the natural frequencies of the structure a long time. Okay, and they were stable. Also in the Misericordia de Aveiro Church. This is, I think, the oldest study I have here. The first sensors were placed there in 2005. I think Hugo and Romeo was involved in this initial study. And as part of the simulation, I think was made here, with the simulation in the party, several sensors were placed over the yards from the sides. And at that time, 33 sensors were installed, and today, 13 sensors are still working. Okay? To measure the formation and temperature. In 2006, there was a very small earthquake in the north of Spain, but almost nowhere. I think it was not felt here in Aveiro, but still the sensors showed there was a small, very small displacement measured inside the church. This is the measurements made in 2005. There are just 2 points here in 2012, 2013, and now we are resuming this study because we saw that the sensors are still working and we want to make a comparison to see if they are stable, if they are still working, and to make new sensors to put there as well. And the final case study is the monastery of Batalha, where we put several temperatures and sensors. We put in this case 3 sensors, 1 for temperature. I think this is the museum shop, right? This is a little bit higher. The sensors were installed here. Okay. These gray squares are not the sensors. This is reflectors for another study. I think you will go with that, but it's not about our sensors. Our sensors are here inside the circles. Okay? And then this is one of the big advantages of this kind of sensors. This is a zoom from our sensor. The optical sensor, it's here. You cannot see it. It's optical fiber, it's transparent. Okay, that's one of the biggest advantages in this case. Well, there are 2 big advantages here. We just have one optical fiber from here. We have a box here, beside the camera here. That's one optical fiber that goes up here and goes all the way to all the points. Okay? So we can multiplex all the sensors in the same fiber cable, and it's transparent. And it's a big advantage for historical monuments that are open to the public. We can monitor without seeing it. And in this case, there are some results here. We made some measurements from July 5 to 9, 2018. Okay? And we can see very, 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 very low displacements. This is micrometers. So 10 micrometers is almost nothing. And these movements are corresponding mostly to temperature fluctuations along the world. We made another week of measurements in 2019, and this is a particularly important date because it was just before COVID. Then we had to stop, but I think now we can, with the PhD of English, we can resume our measurements. In this case, we are very interested to continue this work. So I think this is it about optical fiber sensors. Thank you.
Time for questions.
The question. Paulo, obviously between RISCO and I3N we obviously have a link already, but I think we can develop on this link because looking at your expertise in all the sensors that you can develop, we see that a lot of this can be, for example, linked to one of the presentations that we saw previously from Antonio, where we needed information for forecasting. And then to feed into numerical models to obviously have smarter buildings. We also have another project which is looking at the elderly and looking at for safe and active environments. And for example, these type of centers can make sense, for example, in houses. someone falls, and for example, you need a accelerometer to obviously to measure this. Some other types of sensors could be used for this type of applications, and it's just more not a question, more of a comment that I think we can build on this expertise in the sensors and having applications to the built environment, not only monumentally but for other applications that we're working on.
And if you see other areas in I3M that could be pulled for this cooperation, at
this moment we have a project with the I3N and IT and other international partners that are just about that, to monitor people inside houses, but without any contact, without anything, just through the vibrations to measure the position of the people, to detect falls, to call for help if it's needed. That's all. But I think we can now, especially, we can collaborate more. I began to collaborate with the civil department with Humberto Brum, as you know, and with Hugo. Then Humberto go to Porto, Hugo to Leiria, and then the connection is a little bit lost. But now it's back, so we'll try to resolve it. Okay?
Thank you, Paul.
Finish on time, so
yes, we'll move on to our closing session. We'll have to just wait some minutes for Professor Paul George, which is our rector. He will be here at 4 o'clock, so I think we have like 5 minutes. In the meanwhile, we'll prepare for the closing ceremony. And then obviously I invite you to stay a little bit more, and then we at the end will have a closing. We'll have a bit of port wine and some sweet, some traditional sweets from Aveiro. I know everyone's very anxious for the weekend, and it's been a long 2 days, but hold with us just for another extra 50 minutes if you could. Thank you very much. Okay.
Thank you.
Thank you. So good afternoon once again. I am truly very happy for obviously still having a full room of people. I think that these 2 days were very intense, but they were a measure of our vitality, of our strength, and I felt, and I think you also felt, that we are developing really good research, really high quality research, and I hope we've been able to impress our external advisory committee. Yesterday, Professor Turbo Silva was exposed to kind of like an XXL version of what we would like to show you, but it's kind of like a debriefing of our event, of the meeting yesterday, internal meeting, and the event today. Yesterday we had a broad overview of obviously of our research unit, talking about who we are, what we do, what is obviously our main research lines, numbers, because numbers count, what are our output, what are we doing in terms of scientific output, and 2 or 3 ideas for the future. And we also took in a lot of advice coming from our external scientific advisory committee.
Just to recall, because we have people online in live streaming, our research unit has these three main research areas: assessment and mitigation of risks to the built environment, sustainability, efficiency of resources, and built heritage conservation and safeguarding. This obviously links very well to societal challenges, and I won't be reading this all, but obviously the research scope is there. And what we can see there is these are present in today's challenges. And RISCO, obviously, besides developing fundamental research, develops a fair share of applied research, and we can obviously help partially in some of these very important questions that society puts forward today. Our external scientific advisory committee over yesterday during the meeting, they gave us a lot of good comments, a lot of interesting ideas, and basically I just took 3 or 4 ideas that we got freely off Professor Narodas, Professor Carmin, and Professor van der Leij. And obviously I would just like to enhance the idea that yesterday with what we saw and what we heard from Professor Narodas, that if there's a value chain here that we have to link very interestingly in our conservation research scope, which has to do with the chain that has to do with value, with intervention, and with resources. And that's what we learned yesterday, that obviously we have to link this. It was very eye-opening in the sense that upgrading and maintaining buildings is also about, trying to link heritage with technology. From the contact with Professor Carmin Galasso, obviously he showed us a lot of new approaches to mitigate risks and risk prevention for growing urban areas. Obviously, this is really important to us because we have researchers really focused on this very specific research topic, because obviously its consequence is very high, because we're talking about big areas like urban areas in big cities. And something very interesting that also was put forward was the multi-hazard assessment. We cannot look specifically at one natural hazard or anthropogenic hazard. We have to look at this type of cascading effects that affect us today. And from Professor van der Leij, John, it was very interesting to understand that effectively the idea that we got out is we must walk in the way that maybe buildings in the future can be built like cars. We need obviously we need to improve obviously methods, make smarter materials, obviously use less with more, and basically support our decision making in terms of construction processes with tools that can measure embodied energy, that can measure obviously CO2 footprint. It's important obviously to decarbonize the building stock. These were some numbers. It's just a very fair overview. Our numbers are sturdy in the sense that they're very constant, but you can see that obviously our number of publications has rose. It's interesting to see that we obviously publish in very good journals, Q1 and Q2 journals. A fair share of our publications are in top 10% journals of Scimago, and we have an interesting level of internationalization, which is sometimes something very valuable when we're reassessed, and we have a share exactly the same as the share we have, for example, just with national authors and co-authors. So we mapped out our links. This is our links in this period, but obviously we want to expand on this. We've got good links with a lot of countries. This was taken obviously from an exercise done with our publications throughout that period, and we have strong links to these other countries, but obviously the idea is to keep expanding and intensify this activity. It was important to understand that our budget from FCT RISCO directly represents 14%, but we're able to generate 7 to 8 times more the funding that we get from FCT. This is very important for us. Obviously, over time we've grown, and we have a fair share of money coming in from international projects, national projects, and obviously projects and consultancy attached with the industry. So this is very unique obviously in the university, but not so unique in civil engineering because this is business for us also. So it's important to understand that we are a good group and capable of generating more than we get. It's very important to keep these numbers here, to keep these numbers of ongoing projects. We're in a very competitive space, obviously, but our numbers are these, and we have to maintain these numbers or even increase these numbers. And these numbers are quite interesting for the size of our group, because we're not a very big research group, but unique in the sense that our competencies and our knowledge is valued, and that's why we get these good numbers. Looking into the future once again, as I said, we had a lot of advice from the External Scientific Advisory Committee, very valuable information. This will be then passed on to the rest of the research community of RISCO. But we had kind of like a list that was more or less aligned with what we understood that we should be doing in the near future. And this is kind of like a list of musts. I mean, I won't go through it again, but I would just like to focus on 2 or 3 things that I think are really crucial. And one of them is obviously the strengthening the networking cooperation with international research groups outside and obviously inside. Because we've seen here today that we have a lot in common with other research units, and this is very important for us in terms of visibility. We have to keep obviously very active in the sense that we have to keep a goal of 3 to 4 papers per integrated member, because numbers count. As I said yesterday, everything has to be counted. Some things are not so accountable, but these are numbers that are very important to obviously in a reassessment, reevaluation process will be coming in mid-2023. And obviously to increase the attractivity and output of our civil engineering program, because obviously we need this. We need more researchers, young researchers. They're the production line of our papers, of our publications. They're motivation, obviously. And we, as a research group, as RISCO members, have to incentivize and obviously have to motivate these young researchers. Because the PhD program is highly aligned, or we try to align it with our 3 main research strategic areas. We said it yesterday and we will say it again. We stressed this idea that we put forward yesterday, that we can only grow with impact if we have more researchers. If obviously we get out of this critical dimension, because with more people, with good quality researchers, everything else comes with it. More active projects, more publications, more visibility, more connections, more networking. And so there's no doubt that we have to work on these 2 levels, collectively and individually. And we obviously have incentivized these 2 ways of moving forward, because we need obviously to grow, but first grow with quality researchers, and then, as I said, everything can be put at another level. We need more dissemination activity. We've planned out, obviously, this event, thinking also about the future, also about what we can do. And in the forthcoming months, we'll have to have a newsletter, basically with this image here, the RISCO info, where we have to put ourselves out there, because this is something that also the External Advisory Committee told us, that you have to be cocky in the sense that we have to put our results out there. We have to say we're doing this and we're doing that. We published this paper, we did this as a group. And we have to be more active in terms of dissemination. And RISCO Talks is something that we've talked about this in the past, but now we effectively have to move forward with these type of ideas, and we can organize easily 3 to 4 RISCO Talks per year on specific topics. And obviously the integrated members will be invited to obviously push forward the idea of a RISCO talk. We see these type of talks obviously in other forums, and it's also something else that will put us on the map and collectively give us some more visibility. So I would say this is done for now. We have next year,
but we've got to work on those other two. To finish off, just to say that today these three thematic panels that we had were aligned with our research areas. We had the intervention of our researchers highlighting their work, the younger researchers, and we opened this debate and discussion on the topics of risks, sustainability, and the conservation of built environment. We also had external institutions, which we have a strong relationship, and this was very important because we had here the Portuguese Environmental Agency, we had here Saint-Gobain Weber, and we also had here a national entity from a UNESCO acknowledged monument, the Monastery of Batalha. So this was important for us because these are people, or these are entities that we collaborate with. So here we have obviously the impact in society. We also have an impact internally because we also had invitees from Serão, from I3N, also from GovCop, and we obviously want to strengthen the links with them because we have common interests, and these are outreach activities that we have to do. And after actually this event, this open day, we're compromised to have type of matchmaking events, at least between these research units within the research ecosystem of UA with GovCop. In the first, well, I would say in the first step with these three that we invited for the specific event, I3N, GovCop, and Serão. So, thank everyone for being here today, sacrificing 2 days of a work week, of a precious asset that everyone has is our time. But it's important for us because it's kind of like a strength meter to see where we are. And I think we have our gas tank full. And I think things are going swell, but we obviously have space to improve. But that the External Advisory Committee will obviously give us more information on that in the following days. I would like to obviously thank the Service of Communication, Image and Public Relations for covering the whole event. It was very important, and thank you for that. And thank you to the Secretariat of the Civil Engineering Department, because it's not heavy logistics, but it's tiring, very tiring logistics. And I thank the Secretariat, everyone from the Secretariat of the Civil Engineering Department for, obviously, for this support. I will pass on the word to our rector, Professor Paul George, but just to tell you that afterwards, we would join us, please, just for another 5-6 minutes. Just enjoy a Porto wine, have a sweet, and then have a really great weekend. Okay? Thank you very much.
Well, this is a tough spot to be in. He's mentioned the port wine, so everybody now is in a hurry. And I have the very last words to say to you. And those last words will be that, first, thank you for the invitation. It's really great to be here with you. I'm an engineer. I always feel at home with engineers. Thank you for the External Advisory Board for their contributions and presence here. And also a final word regarding the subject, your drive towards these keywords like risk and sustainability, to say the least. I think those are words that stand for themselves and need very little more to it. We are in a crossroad. We look as engineers towards the future, and we have tools from the past and concepts from the present. Progress so far has been dealt with thinking of everything but sustainability. Progress until our time, this time, has been thought as if the carrying capacity of the ecosystems was infinite, and it's not. So from now on, we start to think about sustainability as the main driving force, as the main conditioning to our activity as engineers, as future planners and builders. So that's very important. We need to be very well aware that we are at this crossroad and that everything we do and plan forward will be important for the next generations. So I'm very pleased to see that RISCO is well aligned with this reality of the world today. And I want to assure you that University of Aveiro and its rector nowadays is also aligned with this and very much enthusiastic about it. So count us as a support, as we have been all the time, and good luck for the future. Thank you.
Vamos então agora dar início ao nosso evento final, que nós precisamos brindar aqui com um Aveiro de honra, que convidamos a todos a estar presentes. Muito obrigado.
Obrigado.